Good morning, guys. It's Naveen, John, and Cole. Can you guys hear me? Could you please type in chat window? Great. Thank you, guys. Just give me one moment here. I'll be with you. Sorry about that. Good morning, guys. Again, it's Naveen, John, on the call. Just want to make sure maybe you're able to hear me. Could you give me another quick yes, please? Okay, thank you, guys. And today we'll get started with a little bit of big data. And during the mornings and during the afternoons and the evenings, I'll switch back to a little bit of Python and Linux, guys. Okay. So that's going to be the plan. The next 2 to maybe 2.5 weeks probably will focus on these things, guys. Okay. So with that, let me just close this one. Vacuum. Resume the share. There is no power in our house. Since the power is back, I'll continue. Okay, great. Thank you. Just thank you for keeping me posted. And let's get into the world of big data, guys. Big data is a slightly theoretically heavy topic. We'll try to simplify it as much as we can. And just one more minute here. Let me come back here, back to the Excel. And let's say here is downloads. Let me go back here. Schedule one. Okay. Should be good enough. Okay, close this one. Sharing my screen again. And bringing up the screen, guys. Okay, so let's get started here. Let me hide this one. Share the sound, hide names, floating meeting controls. Okay. Can you hear me now, guys? Could you? I just plugged in my earphone. I just want to make sure you're able to hear me. Can you hear me?
Sir, your voice is very slow, sir.
Can you hear me, guys? Priyusha Ganesh, can you hear me? Niharika?
A little bit low, sir.
But it's very low.
Very low, really. How about now, Sibu? Is that any better? Harsha? Okay, thank you. Sorry about that. Don't know what was the problem there. Okay. Somewhat okay. Okay, just keep me posted, guys. I'm just using my earphone. It's much closer to my mouth. But just keep me posted if it gets too difficult and things like that. Okay, guys? So let's get started with a little bit of big data. Okay. With a little bit of introduction to Linux, I think we should be good. We also need to get into our, while I do this, let me bring up back to the brief here. So bring this up, Cloud Labs. So let's do sign in. While it's doing sign in, let's come here and get started, guys. So, okay. So what is big data? So formal definition is big data is a term applied to data sets whose size is beyond the ability of commonly used software. So in other words, it is a term applied to data sets, which means it is nothing but it's a data set. Data set is a file. The problem is it is beyond the size, beyond the ability of commonly used software tools to capture. Means, imagine, here's a laptop. And let's say we have 1 GB of data. Let's say for the sake of simplicity, here is 1 GB of data. Now you can take 1 GB of data, you can store it in your laptop, no problem. Okay, what is this? This, so I come back here. This is, we're able to capture 1 GB of the data here. And what is it? It is commonly used. But imagine a scenario, let's say, for the sake of simplicity, here is 100 terabytes of data. Okay, in other words, more precisely, let's say I come back here. put it like this. We'll say 100 terabytes of data. Now, to understand terabytes of data, let's also come back here. Choose this one and say 1 terabyte equals to 1000 gigabytes. Then we have 1 petabyte, which equals to 1000 terabytes. Then we have 1 exabyte, which is equal to 1000 petabytes, and then goes 1 zettabytes, which is equal to 1000 exabytes, and it keeps going. Currently, most of the enterprises, they are here. They're dealing with multiple terabytes of data. If you take the Facebooks and the Yahoos, they are in this range. Petabytes and exabytes of data. They work with petabytes and exabytes of data, guys, okay? Then we have the NASA's, the astronomy, or astronomical scientific industry and things like that. They are probably dealing with this amounts of data, this zettabytes of data and things like that. They are too far beyond. But most of the organizations are dealing, they're trying to mine terabytes of data. And how much is a terabyte? That's 1 terabyte is 1000 gigabytes. So back here, what is happening is, if you have, let's say, 100 terabytes of data, you try to take the data, put it onto your laptop, computer, or single server, you cannot. What do we say? That's where we say, this is the size of the data. It is beyond the ability to capture. Capture means store. We are unable to store because it is too big. Okay, then what is that? That is big data. If you are not able to capture, if we are not able to store, we will not be able to manage it. First, you store it, then you'll be able to manage it. What do you mean? You manage means you write a program on that. And what will you do? You process it further, you analyze it further within a tolerable amount of elapsed time. In other words, first of all, we are not able to store it, so we cannot manage and process the data irrespective of the time. There's another scenario. Come back here. Take, let's say, this one. Let's say here is another laptop. In this scenario, what we are saying is 100 terabytes of data is too much, too big of data, so we're unable to manage it. But take a scenario where you have a laptop and let's say back to 1 GB of data. Let's say this is 1 GB of data. Now what we have done is, we have successfully saved the file into our laptop. Then what we are doing is, imagine we want to do some kind of processing on this data. We have written a program. The program is processing this kind of data. And what's happening is, back here, let's say this is taking 10 hours of time. Say this is taking 10 hours of time to process the data. Now, we're able to process the data. Here, we are successfully able to capture and manage and process the data. So no problem. But imagine the user comes back and says, hey, we need this to be done in 1 hour of time, not 10 hours of time. We want this to be done in 1 hour. We cannot wait 10 hours for this processing to happen. So now what is happening is, we come back here. The 1 GB of data is small amount of data, but within a tolerable amount of elapsed time. Even though we're able to capture the data, which is store the data, but we are not able to process the data. We're not able to manage and process the data within a tolerable amount of elapsed time. What is that? In such a case, that 1 GB of data can also be called as big data. Why? The data is small, but the processing is taking more. And what is happening? It is beyond the ability of commonly used software and hardware, to be more precise. The hardware and the software that we have is not enough to, it is enough to capture, but we are not able to manage and process the data. In such case, even a small amount of data can be called as big data. Everybody with me, guys? Quick yes, please. Can you give me a quick yes? Okay, so let's move one step ahead. Back here. So snap it. Back here. So the world of big data or the big data landscape, there was 5 exabytes of information which was created between the dawn of civilization through 2003, which means, visualize or imagine, this is a timeline where somewhere here, maybe it's something like historically, it is 1 BC. And let's say, I think 1 BC, 180, whatever it is. Let's say somewhere here we are 2000 and somewhere here is 2003. Okay, so what is happening is, if we were to take all the data from right from the time when the civilization, humans have started documenting the data, writing the data. If you were to digitize all the data from here up to this 2000 years, okay, what is that? Approximately, it is expected that would be around 5 exabytes of data. 5 exabytes. 1 exabyte is, again, let's say, come here. But let's say back here, for your reference, 1 terabyte equals to 1000 gigabytes. Then you have 1 petabyte, which equals to 1000 exabytes. Then you have 1 exabyte. Oops, sorry. Terabyte. 1 exabyte equals to 1000 petabytes. And then you have 1 zettabyte, which is equal to 1000 exabytes, and it keeps going like that. So 5 exabytes, if you come back here, 5 exabytes is here. It's about 5,000 petabytes of data, which means in 2000 years, the human civilization, if you put all of that, it has generated about 5 exabytes of data. It took 2000 years. But what is happening? Here is what is happening. That much information is now created every 2 days, which means every 2 days now, what the entire human civilization has taken 2000 years to generate, today we're generating in just 2 days. Why? Twitter processes 340 million messages per week. Data generation in last 1 year is equivalent to data generated in last 15 years. Why? Because everybody's going to Twitter. Whether you're marketing, whether you're sales, whether you're fun, whether you're watching cricket or watching a movie, Bahubali, or whatever it is, everybody's going to Twitter. They're posting, tweeting, and they're discussing. Many serious businesses are running. The stock market sentiment is being measured based on the Twitter and things like that. 340 million messages a week. One message in Twitter's database is equal to 300 to 500 rows of data. Okay. And if you multiply with that, with 340 million, that is close to a billion probably. What that means is in 1 week, they are generating 1 billion. They are adding 1 billion rows of records into their database. In other words, what it means is, for an application to generate that amount of data, it would take 10 to 20 years if you go back a few years. Now today, Twitter is generating that in a week. Then come to Facebook, generates users. Facebook users generate 2.7 billion comments and likes. So in other words, again, that is billions. What would take 10 to 20 years is being generated in a matter of a day or a week. In Facebook, Amazon stores 1 billion objects bi-weekly. In other words, again, that is a very huge number. When you say 1 billion, it is 1,000 million. 1 million is 10 times. It's like 10 lakhs. eBay stores 90 petabytes of data about customer transactions. Enterprise information is no more in terabytes and petabytes, but is in exabytes and zettabytes. In other words, okay, petabytes and zettabytes, exabytes, these are very large organizations, but most practically, we will end up working with terabytes of data. And it doesn't really matter for us, no matter how much it is, once it is that stage, whether it is terabytes, petabytes, or exabytes, it doesn't matter. But we'll mostly start working with big data in the companies, which will be here. So, so what that means is, imagine for the sake of simplicity, let's say, me blank this one, come here. Imagine for the sake of simplicity, we are generating, this is, let's say, we put a small dot here. Let's say this is 5 exabytes of data. This is, let's say, 5 exabytes of data, which the entire human civilization has taken 2000 years to generate. And what's happening? The same amount of data is being generated every 2 days now. Okay, which means in a year, what is happening is, if we were to take the amount of data being generated, is this much, approximately or roughly. In other words, if you compare this one with that one, what is happening is, it is not double, it is not triple, it is not 10 times or 100 times. It is exponentially huge. Exponentially huge means it is to the power of something else. Okay, that is what is happening. It is to the power of something else, guys. That's what is that? That is big data. And why do you think companies are generating that amount of data, guys? Can you take a guess? The hint is on the screen. Why are the humans generating that amount of data? Can you take a friendly guess? Okay, Twitter, Facebook, Amazon, eBay, mobile phones, YouTubes, Googles, and so on. Social media, mobile. These are one of the primary reasons why there is so much of data getting generated. Everything, IoT, everything and anything is generating data. The smart cities, every street you go, the CC cameras and things like that are generating the lot of data, guys. That is what is happening. The news and so on, guys. Okay. So what is that? The challenge, or in other words, when we have so much of data, we also have a problem. What is the problem? Large scale data storage and retrieval. In other words, if, let's say, if we have one laptop, one computer, one server, and we have hundreds and hundreds and terabytes of data, what can we do? We are unable to store the data. We cannot store the data. If you cannot store the data, we cannot process the data because the data is large or big. Pardon me. And if you cannot process the data, you will not be able to retrieve the data, the results of the data, which is you will not be able to analyze and get the results of the analysis. And what's happening is, another big thing is, they're all unstructured. What is unstructured? We'll try to understand what is unstructured. What are these? At a slightly high level, we say, with big data, the two main problems is storage is one problem and processing is another problem. What is that? These are the two main problems of big data. Okay, guys. So now let's go one step here. Understand what is unstructured data. For that, let's try to understand what is structured data. Data can be organized in well-defined structures. If we take data in a database, it is supposed to be in the form of tables. The tables are nothing but well-defined structures. That is nothing but structured data. Okay, so if you take, let's say, a student database, there is a table called student table. We are maintaining the ID, first name, last name. What is it? ID is numerical data. First name and last name are textual data. Date is data type. Numerical data. What is this? That is called metadata. What is this? It is well defined. You can also store it in the form of vectors and arrays, but most of the time, tables are referred as the structured data. Relationships are in data defined with the structure. In other words, what it means is, in a database, you have a parent table, you have a child table, You have a grandchild table. What is this? This is called relationships. Then what you have is you maintain constraints. Each parent can have multiple children. Each child can have multiple grandchildren. And are there any additional rules? Well, those are called constraints. What is that? That is the database. That is how we store it. What is that? That is called structured data. Structured data is generally referred as the data in the database, where we know everything about the data. That is called structured data. You can think of structured data as the rivers, water in the rivers of the world. Okay, what is there is only 10 to 20% of the water in the rivers of the world. 80 to 90% of the water in the seas is in the seas and the oceans of the world. What is that? That is called unstructured data. So there is unstructured data. What is happening in the world of unstructured data? Unstructured data is the seas and oceans. Say, come here. Is the seas and here is the oceans. More precisely, this is the oceans and we call this as the seas. So what is unstructured data? Unstructured data is organized in an arbitrary manner with no predefined structure. What it means is, imagine a resume. Resume of, let's say, Suresh may be different from resume of Pratyusha, may be different from resume of Vishweshwar. Everybody will prepare the resume in their own way. Not everybody has to prepare their resume in the same way. In other words, there is no arbitrary structure. You can do it in any way as long as it is conveying that you're good and you have the content and things like that. What is that? That is unstructured data. It is referred as free text. The images, the audio, the video data. Today, with the machine learning and the deep learning inventions and innovations, they are analyzing the video and the audio data and they're analyzing the image data. Very, very powerful techniques have come into the world and pictures, and that's what everybody is trying to understand. The businesses are trying to understand. That's where they need the people and things like that, guys. Okay, so it includes not only textual data, the images, the videos, and the audios. What is this? This is unstructured data. What is unstructured data? You can think of it as the oceans of the data, water in the oceans. 80 to 90% of the water is in the seas and oceans. And what is it? That is unstructured. In unstructured data, we have something called semi-structured data. An example of semi-structured data is XML. Later, we will look at this. But semi-structured data does not conform to a formal defined structure, but entities belong to classes with attributes. In other words, semi-structured data is also something like structured data. So let's say here is an example of an XML document. Let's say we have something like, here's a group of documents. Say less than documents, 3, 4. And here is the closing tag, /docs. And let's say come here, 1, 2, 3, 4. Here is, let's say the first doc. You'll see, say ID equals to 1. Let's say name equals to something. So let's say equals to ABC. And what is this? This is the first doc. And let's say /D/C. Close the tag. Then come here, we copy this one, paste it here, we change this to, let's say, ID equals to 2. And change this to, let's say, BC. And you visualize 1, 2, 3, 4. It keeps going like that. So what is this? If you look at your HTML, if at any point of time you happen to look at HTML also, well, a parent, a child, and grandchild, you can keep going like that. What is that? That is semi-structured. We call that a semi-structured because it has a touch of structure with the top node. We call that as node is acting like a parent. The below one is acting like a child node, another child node, and things like that. What is happening? Because there is a task structure, we call that as semi-structure. Data cannot be processed as effectively as the structured data. It is not as good as the tables in the database, but still, since there is a touch of structure, we call that as semi-structured data. XML and JSON objects we'll see in the coming up days are examples of semi-structured data. You can think of this as the seas of the world. This is the oceans of the world. And then the structured data is the rivers of the world. Okay, what is happening today is big data analytics. If you come back here, big data analytics, or in other words, today, most of the businesses are going to their databases and data warehouses. And what is a data warehouse? We'll try to understand. They're performing their analytics. They perform the analytics and they try to find insights. It's like businesses are like fishermen. They're going to the rivers and finding the fish in the rivers. What do they find? Well, they find fish. But what is happening? That's where the seas and oceans are coming. If we can find fish in rivers of the world, we can find big fish in the seas and oceans of the world. Well, what is big fish? Big fish is big insights, lots of insights. What is lots of insights? Small fish versus big fish. Big fish is the shark, dolphins, the whales, and things like that. In other words, they're able to find lots and lots of insights in the unstructured data. What is an example of that? That also we'll take a look at that in a moment, guys. Everybody with me so far? For now, structured data is rivers, unstructured data is ocean, semi-structured data is the seas of the world. Everybody with me? Quick yes, please. Then a few more things to keep in mind. Batch data versus real-time data. A few terms and terminologies we need to be familiar, guys, okay? Data is collected in a batch. So let's say come here. Batch data is something where data is collected in a batch at periodic intervals. Imagine, I'm sure every one of you have bank accounts. What do banks do? At the end of every month, or maybe at the end of a month and a half or 2 months, they'll send you a bank summary saying that, hey, these are list of transactions. What are they doing? They are taking, let's say there are 1 million customers in a bank. They will take 1 million customers. What is that? That is called a batch of customers. Every 1 month or maybe 2 months. What is it? That's a periodic interval. What do? They're taking all the data, which means they're collecting the data. There is a delay. Why are they waiting 1 or 2 months? Because that is the nature of that. We don't need a bank statement every day. Maybe once in a month, once in 2 months is enough. So what do? They wait that is delay in the availability of the data and make the data available at a certain periodicity. Why? Why are they maintaining it? Because that is the nature of it. And then what do? They collect the data. What is that? That is called batch data. A process like that, a use case like that is referred as batch data. What do? They process it and they analyze the data. What are they buying? What are the popular transactions? What are the popular items they have purchased and things like that? They get insights like that, guys. Okay, so that is as part of the analysis. But batch data means you're collecting the data. Real-time data is, imagine we go to imagine Praharsha. She goes to a store. She purchases maybe Reebok shoes. And then what is she doing? She's using a credit card or maybe a debit card and swiping the card. What's happening? The moment she swipes her card at the store, data is collected in real time. The card is sending the Praharsha's access or the credit card the information to the bank. At that time, in about a few seconds, she's getting the response back from the bank saying that yes, she has the balance, yes or no. What is that? This is called real time. It is happening at that point of time. And what's happening? The data is delivered as it gets generated. Data is delivered to the bank. The bank is responding and generating the answer. There is no delay. In other words, once you swipe your card, in a matter of few seconds, the entire transaction is done. That is real time. If it is going to take a few minutes or maybe a few hours, then nobody will use credit cards. Okay, there is no delay. Why? That is the nature of it. Generating a bank statement is different from swiping a credit card. If you need a bank statement, you can wait 1 month, maybe 2 months. There is nothing wrong in it. That is generally done by the banks. They take a group of customers. That is called batch data. But when you swipe a card, for every person, the data needs to be validated, verified, and checked and seen if the balance is there or not at that point of time. That is called real time. That is referred as real time data. In other words, the mantra of real time data is swiping a credit card. The mantra of batch data is the bank statement. Everybody with me, guys? Quick yes, please. Okay, move to the next one. Okay, so what is all this, guys? This is data. What do? We take this data, we have to store the data, we have to process the data. What do? We have to architect the data. What is that? That is called data architecture. Today, every business has data in their database, but there's new things happening, which is social media, IoTs, the mobile phones have started generating their data. And what is happening? The data is growing exponentially. What do we need to do? We need to do architect the data. It is not just architecting the applications. It is architecting the data which is becoming important. The data architecture comprises of models, policies, rules, or standards that govern. What does that mean? When we have data, what is a good way to collect the data? Collecting the data. How do you collect the data? What is more precisely a good way? If you collect the data, if you are able to get the data, how do you store the data? What is a good way to store the data? Then how do you arrange the data so that the processing will become easy? Then how do you analyze the data so that the integration will become easy? And then how do you put to use? In other words, today, everybody, data is the new oil. Data is the new oil. Data has become the most precious resource. Oil was one of the most precious resources of the world. Today's data is becoming the most precious resources of the world. And what are businesses doing? Businesses are trying to find insights in the data. But what was happening? They were going to the databases. It's like the fishermen were just going to the rivers and finding the fish. But what is happening? Today, they have come to know about the seas and the oceans. If you can find fish in rivers, you can find big fish in seas and oceans is what. And what's happening? That's why everybody is after data. But what is it? Considering all these things, how to make the best, how to store the data in a best way is what the data architecture is about. Data is usually one of the key architecture domains that forms the pillars of an enterprise of architecture. In other words, that is becoming more and more important for the businesses to understand how to store the data. Data architecture is becoming very, very important is what it is, guys. Okay, everybody with me? Quick yes, please. Everybody okay with this slide? Okay, so that's where the big data, what's happening is exponential amounts of data is coming. Big data is comprises of the broad components, the data part of it, then the analytics and the delivery and the consumption. The data, we have data coming from social media, mobiles, IoTs, and others. What do? You store it, then you try to search it, you process it, then you try to integrate it, and then you try to retrieve it. You also take care of the security. Who should access what kind of data? If it's very confidential data, you don't want others, everybody to access it. What is it? That is security. What is it? These are the aspects to be kept in mind these are some of the aspects that an architect needs to keep in mind. Then what do? Once you store the data, you process it and you analyze the data. If you just have water, it is not just enough you look at that. What you need to do is you need to take a boat, you need to go into a boat or a ship, and you need to fish in the water. You need to search for fish. What is that? Searching is analyzing. You are analyzing the water. What is water? What is data? What is it? That is where the concepts such as business intelligence, reporting, visualization, statistical modeling, data mining, and the most popular today, the machine learning, the predictive modeling, the latest and the greatest buzzwords, deep learning, are coming into the picture. These are unraveling some truths which people are not able to, which are making, which are giving some very, very good insights, guys. In other words, this is the fishing. Data is water, analysis is where you're doing the fishing. Once you fish, once you understand the insights, what do? You consume it, you try to take action. Implementation of analytics solution, which means when you analyze the data, you understand something. Based on your insights, what do? You should try to take decisions. You try use so that it will allow you to do some actions. So that's where businesses are building applications which are like business decision platforms. These platforms will take the data, they're internally analyzing, they're internally storing and analyzing the data, and they're saying, hey, you should do this action, you should do that action. That's where they're adding interactivity, they're customizing it, they're providing real-time insights to multiple devices and things like that. Okay, what is this? This is what the data architecture is about. More precisely, this is what the big data is about, and this is what big data analysis is about, analytics is about. Everybody with me, guys? Quick yes, please. Cool. So let's go one step deep into these aspects and see what we have here. So theoretically slightly heavy, guys. Big data, the cloud computing concepts, which we are going to be seeing in the coming of days, are going to be slightly heavy theoretically. So just bear with me. Let's see what we can do here. So in data, there is different kinds of data. Okay. There is user generated data and there is application generated data. User generated data is what user generates, which means the data that we enter in our documents or blogs or emails is user generated data. It's human generated data. But there's another set of data, which is machine generated data. When you access a website or when you access any application, what is happening is every application is making a note. Imagine you access gmail.com. What's happening? Gmail is tracking your IP address. What is the date and time? What were you looking at? What did you click on any ads? What is this? All these things are being tracked by the application. What is that? That is called application generated data or machine generated data. They're logging almost anything and everything online. What is it? All this data is saved in log files. This is becoming the unstructured data. The data generally in the database, these are not the database. Data in the database is the reverse. This is the data which is in the files. They don't have any metadata. They don't have any more information about them. It's purely raw data, that is the logs data. But what is happening? If you're able to understand, analyze these log files, there's a lot of insights we can get. Device generated data, again, machine generated data, your CC cameras, your point of sale. You purchase something, and what's happening is when you're at the time of purchasing, they're making different kinds of recommendations and things like that. That is called point of sale. CC cameras are capturing your audio data, video data, and other kinds of data. What is that? That is unstructured data. And what is happening? They're trying to understand different kinds of patterns in these data. That's what the artificial intelligence, the deep learning, and the machine learning is what is coming to your rescue, guys. Okay. Then the internal data. For an organization, any data which is within the organization is said to be internal data. It is generated internally in an organization across business processes. So sales app, logistics app. If the data, pardon me, sorry about that. If the data is within your organization, we refer to that as the internal data, guys. Okay. Sometimes the data which is part of the organization, say, okay, let's escape one moment. So, say, okay. Sometimes imagine a bank. Imagine Ganesh applied for a loan. What do banks do? Bank requests the external bodies, for example, the credit bureaus, and say, hey, can you give me the credit history of Ganesh? How is his credit? Is he a guy who takes the loans often? If he takes the loans often, does he return them? Is he paying the installments properly? Or what is that? That is called credit history. That is maintained by external entities such as credit bureaus and other data aggregators and things like that. What's happening? That data is not internal. That is the data which you're getting from external organizations, that is referred as external data. Okay. The internal data, let's say, choose this one. The internal data in an organization is like the rivers in an organization. The rest of it is the seas and the oceans of the data, is what it is. And what is the promise? If you can find insights in the internal data, then what's happening is businesses are being promised you can find big insights. You can find big fish. This is small fish. If you know how to find fish, then you can find very, very huge fish from your external data. The external data also could be the internet data, the data on the internet, the social media, the mobile, the IoTs, and other kinds of data is what it is, guys. Okay, so what are these? All this data is what the data is about. Today, companies are trying to get each and every, or in other words, all these kinds of data, and they're trying to analyze the data. They're trying to find the fish or the gold, is what we can think or we can say, guys. Okay, everybody okay with this slide, guys? Quick yes, please. Cool. Okay, gentlemen, ladies, Let's take a short 5-minute break, guys. Give me this is a slightly heavy one. So 11:54. Let's take a short 5-minute break. Everybody okay with that? We'll continue the journey. Thank you. Sorry about that, guys. I'll have a glass of water here. guys? Are you back? Can you give me a quick yes, please? Great, thank you guys. So guys, in about 10-15 minutes, I may take another short break for 10 to 15 minutes for a quick client call I need to take. So just bear with me for today, an unexpected call I need to take care. So just kind of bear with me, guys, okay? So let's continue the journey, guys. Let's see what we have here. Okay, so think of data is like the water, and what we want to do is we want to find the fish in the water. The fish is nothing but the insights. So what we have, what is going on here is, imagine in a traditional business, traditionally what was happening was they would have a database. Inside database, they will store different kinds of information. So imagine here is Revati. Let's say what will be stored about Revati's information is she's a woman, or she's female, she's single. Let's say she's between ages 25 to 30, and let's say she's making $80,000 and above. What is this? This is traditionally the kind of information which is saved in a database. This is also referred as demographic overview. In other words, if you go, when you have this kind of information and you try to find insights in a database based on this one, you generally find, if you try to analyze this kind of data, you try to find some insights. That is, you can make some very limited business insights. That is what this one is about. Okay, but this is limited business insights is what it is. Now imagine the same business if they are also accessing the data of Revati. They also go to internet and they access her data. What is happening? Imagine Revati is a friend of Pratyusha. On Facebook, she's saying, hey, she loves to travel. She also has a subscription for a fashion magazine. She's chatting maybe with somebody, maybe Pratyusha, she sends a message. She is also into fashion. She has an annual membership at the local health club. So she's also into the sports, and she's spending about $400. You add up all these expenses, she's spending about $400 per month. And she's actively involved on the social network for 1 to 2 hours. What are these? This is the kind of information that we cannot find in a database. And in what way is this kind of information useful? Well, she loves to travel. So what can a business do? Well, now businesses can target Revati because she's into travel. And let's say she's traveling to maybe Vijayawada or maybe Mumbai or maybe Delhi. What can they do? They can probably give her, maybe she's going by bus or maybe by train. They can probably give her maybe an air ticket, promote her an air ticket saying that, hey, at the same price today, the prices have been reduced and you can go by air. You don't need to. You can go by air in about 1 or 2 hours to your place rather than traveling 10 to 20 hours. What will happen? Well, she'll go more early to her destination, to her home. She will spend more time with her family. Spending time with family is the most valuable thing in our life. Okay, and she's also into subscription magazine. Maybe she was chatting with Pratyusha. She says, "Hey, I ordered this fashion magazine." So now, what can we do? They can target. They can target her, and they can maybe give her recommendations of better fashion magazines, saying that, hey, if you like if you like this fashion magazine, this is a better one with much more better stuff in it. Okay, then she's at the local health club. She has taken an annual membership at local health club, means she's into sports. Now, if you know she's into sports, what can we do? Well, we can sell her Reebok shoes, we can sell her Nike shoes, maybe Adidas and Puma. These are the kind of decisions you will never be able to make by just looking at this kind of data. And she spends about $400 per month. For $100, if you're able to buy shoes, you still have $300 capacity, which means she's spending $400 on personal care, which is the beauty care products, the hairs, the dyes, and things like that, which means there's a lot of other products that we can also recommend. What is the problem? And these are the kind of insights that they reverse. The traditional databases will never give us. These are the kind of insights that we generally get from the seas and oceans. What is that? That is internet. What is it? That's your Twitters, the Facebooks, the WhatsApps, and things like that. What is this? This is called psychographic order. For you guys, you may think these are the examples of the insights which might be simple, but for businesses, this is very, very valuable. If you know the technique, how to find for Revati, this kind of information, what are businesses doing? Businesses are using that kind of techniques on millions and millions of customers. And what are they doing? If they find 1 million customers who are interested in Reebok or Nike, and they go to Reebok and Nike and tell them, hey guys, I have insights. I have the customers who might be interested. I have 1 million customers who are interested, who might be interested in your shoes. What will Reebok and Nike do? They will give you any amount of money. Everybody catching that, guys? Quick yes, please. What is that? They are not just big fish, they are very big fish. What is that? They are big insights. Catching it, guys. Quick yes, please. So psychographic Oreo, the mantra of that is, they are the examples of the big insights. Demographic Oreo is the example of small insights or small fishes, what we can think of, guys. Okay. So come back here. Moving to the next one. Then we have the internal data. Pardon me. Come back here. Snap it. This here. So hide this. Okay. So what is internal data? Generally, internal data is the data within your organization. So come here. Here we go. Data generated inside an organization. Example, in a bank's credit card business, data is generated by multiple processes. Data is coming from multiple processes, multiple application. There could be an accounting app, an aggregated data. Aggregated data is data, again, being stored of different customers in a single application, which contains data from multiple applications. Transactions data. These are all the transactions which are happening in your application, the e-commerce data and things like that. What is this? All this data is within the organization, that is again the rivers of the world. Water in the rivers of the world, that is referred as internal data. Okay, what is the problem? Well, there is no problem. We can find fish, but we cannot find big fish. We can find insights, but we cannot find big insights. That is what is internal data. So what is external data? External data is the data which is available in external organizations. Every business generally does not traditionally store all the data. So what happens? They borrow the data from external organizations, that is referred as external data. That could be a market research, just trying to understand which companies are good, which products are good, which will be good, which will not be good, and things like that is market research. Data aggregators is, this is a group of companies, all they do is they just collect the data from different places, they store it and they sell the data, that is called data aggregators. Benchmark studies. After you do research, you try to come up with some analysis and you benchmark them, that is benchmark studies. Then regulatory authorities, any compliances and things like that. If you have any data, these are the rules that you need to follow. You cannot store credit card information. You cannot store bank information. Those are some, there are some authorities which enforce. What is that? That is the other kind of data that the companies may not have. What is that? That is called external data. Again, credit bureaus. Back to Stravia. Stravia applied for loan. And what happens? Well, before a bank gives a loan to Stravia, they need to make sure she's a good customer. If she's a customer who's paying the loans, then we can give her. But if she hasn't been paying the loans that she has taken earlier, then we should be very careful giving a loan to her. What do you do? That's what the data we get from credit bureaus. They store the credit history of all the banks and things like that. So that could be, these are the public data. It could also be the data from the courts. You have any legal cases going on? Are there any cases filed against a particular customer? That kind and things like that is generally the court data from the courts and things like that. In other words, short and sweet, external data is the seas and oceans of the world. Is another way to think of it. Everybody with me, guys. Quick yes, please. Okay, now remember, data is like the water. And what is it? Water is important, but more importantly, it is not just the water, but it is the quality of the water. What is that? Well, it is not just the data, but it is the quality of the data which is important. What happened is a few years back in Great Britain, one of the popular newspapers ended up publishing this something like this, saying pregnant men. Great Britain, 70,000 men were pregnant between 2009 and 2010. The hospital data revealed that these men went to hospitals for pregnancy-related services and had obstetric exams performed among other prenatal treatments. What is that? That is referred as a horror story. In other words, if you have data but the data is not good, the result will be horror story. In other words, imagine a movie. If the story is good, the movie will be good. The movie will end up good. If the story is not good, well, the movie will not end up good. Okay, what is this? This is an example of bad quality data. You should not only have water, you should not only look for water, but you should also look for good quality water, is what is important. Okay, so here is going a little bit deep into this scenario. What happened is, here is what happened. These men had gone to the doctor for the procedures that had medical codes close to the medical code for obstetric services. In other words, imagine there were a group of men who went to the hospital. They had done something in the hospital, some surgeries or maybe whatever it is. And what happened was they were the medical representatives. What were they doing? The employees working at the hospitals had incorrectly coded the procedures by carelessly entering numbers. What it means is these representatives, medical representatives, instead of entering something like I01, maybe they entered something like I01 or maybe I801, I81. And as a result of that, because of the automation, what was happening was wherever it was a women, instead of the automation, instead of wherever the newspaper program, instead of picking up women getting pregnant, it was picking up men getting pregnant because of the mistake that which was made by the service representatives. In other words, this is nothing but an error. What is that? An error is what refers to the data quality. It is not only your data should be not only you should not only have the data, but you should not have error data. You should have good data which is trustable. What is that? That is the quality of the data. You don't go into bad waters, dirty waters, and fish will look for fish. You go and look for fish in the good waters is another way of thinking of it. What is that? That is called data quality. What is the quality of the data? Having less errors in the data. Or in other words, having no errors in the data is what is important. That is the story of the data quality. Everybody with me, guys. Quick yes, please. Pardon me. So let's see what that means. Let's continue the journey. So this is going to be slightly heavy theoretically, guys. Big data. Just bear with me for the first few days. And let's see what we have. Data quality. Missing data. So missing data, it is input process not capturing all the data or not mandatory in the input process. Imagine we are entering some data in an application and we do not enter some data, that is called missing data. It's simple. As simple as that. Sorry about that, guys. Today I'm having a little bit of cold, so just bear with me. Junk values. Junk values is entering incorrect data. Okay, so you imagine somebody, you have an application which is asking for a name. You should, let's say, it is a field called name. And let's say you enter Psi, that is good quality data, but you enter something like that is bad quality data. Add some of that is junk data. That is what it is. Okay, so what do? You have to validate. Your application has to validate more precisely. Then you have definitions. Inaccurate is you have a field called name. So you have a field called name, but what you're doing is instead of name, let's say you gave it something like, okay, for the sake of simplicity, to name. What is that? That is not a correct definition. Name should be name. What is that? That is called inaccurate definition, incomplete definition, not right definition. Multiple definitions. You say first name and last name. You don't say name, something like that. Or in other words, giving different definitions which are not professional or appropriate. That is about the definitions. Then the completeness. Incomplete data, again, it is something like missing data. You should have completed something, but you left it blank. That is nothing but missing data. Validity. What is validity? Somebody's age will be anywhere from 1 year to maybe 100 years, or maybe 110 or 120. You cannot enter something like 200 or 300 years data. That is invalid data. That is also inaccurate data. Okay, timeliness. If you swipe a credit card and it's taking 10 minutes or maybe 1 hour to get back a response, then there's a lot of delay. What is that? That is also referred as a quality of the data. Okay, consistency. Pravalika. Her name is Pravalika. In the world of big data, what will happen is her data will be stored in different servers. And so here is Pravalika's data. Let's say, here's Pravalika's data, Pravalika. And what happened is, here is also a third server saving her data as Pravalika. So when a request goes to server 1, we are returning Pravalika, no problem. When it goes to request 2, we're getting Pravalika as no problem. But for some reason, when it goes to server 3, we are not getting Pravalika as her name, but we are getting some other name. What is that? That is called inconsistency. Your data cannot be inconsistent. What is this? All these are referred as data quality issues. When we work with data, we need to have all these things in mind. Generally, what we do, there are different kinds of rules. There are different kinds of techniques and concepts that we do. That is what we will learn in the coming of days using various tools, which will handle and tackle all this kind of things. Everybody with me, guys, quickest ways. So this is where the complexity of the data comes into the picture. Say, snap it. Here is the distributing data complexity. It is distributed data. Distributed computing complexity means, generally, if you have data in a single server, okay, we have data in a single server, that is not distributed. But if the data is very, very big, let's say, here is some huge amount of data. And what is happening? The data will not fit on a single computer. What do? We generally take multiple servers. You save the data into multiple servers. Here is the second part of the data. Here is the third part of the data. And what is this? When your data, this data was originally only one file, but because it is very, very big, what we do is we save it into multiple servers, multiple parts of it. That is called distributed data. This is called distributed storage, which we are going to get into the depth of it in a bit. Then what do? We take this data and then we process it. What is it? The processing is what is called distributed complexity, distributed computing. When you work with big data, taking a large amount of data, storing it in different servers is complex. And if you are somehow able to take the data, here I'm showing only 3 parts of the data, but in real world, the big data is split into hundreds and thousands and millions of parts, smaller parts, and saved in different servers. Okay, so storing is a big problem. A bigger problem, that one is processing it. What is it? That is computing. Together, they're referred as distributed computing. You're not only your data is stored in different computers, it is distributed. Even the processing is also super complex. That is what we'll try to understand. So in other words, what is distributed computing complexities is the big data. The complexities that we come across with big data is referred as distributed computing complexity. What does that mean? Well, some of the problems is availability. When your data is stored, what can happen is some of the servers can go down. What will happen what will happen to your data? Well, your data gets lost. So what you need to do, you need to make sure your data is available. You just cannot afford. Data is consistency. We have seen Pravalika's on one server name, whether it is name, credit card address, or credit card number, gives you some information when the request goes to one server, you're getting correct. But when for some reason, when the request goes to another server, you're getting a incorrect information. What is that? That is consistency. What do? Well, you need to take care of that. Event synchronization. When servers fail, when you lose the data, Some notifications need to be gone on, need to be given so that the clients who are using the data are aware of that and things like that. Bandwidth limitations. When we work with big data will take up the complete network of the data. So what do you do? How do you handle the bandwidth? Partial failure, whether it is a complete server going down or just a few CPUs or the hard drives going on. What is that? That is partial failure. Then what do you do? Cascading failure. Sometimes when one server goes down, when this server goes down, that may result in other servers going down. When the other servers goes down, what will happen? The data will also go down and get lost. What do you do? That is called cascading failures. What do? You write code. In the world of big data, we need to write code for all these things manually. It's like saying you have to be a mechanical engineer to drive a car. If everybody has to be a mechanical engineer to drive a car, very few people would be driving a car. Very few people will be driving the cars. Okay, well, there's a lot of depth up here and there. If you don't, that's okay. Event synchronization is when one event happens, a lot of other events need to happen, notifications and things like that. That is what is event synchronization. So we're going to talk about each of these things in detail. I'm coming to that. So what do we do? Traditionally, what we do is we write code. If you have to work with data, it's like you have to be a mechanical engineer to drive a car. What is the problem? That's where Hadoop comes to your rescue. Hadoop comes to your rescue. And what does it say? It says, the mantra is you don't have to be a mechanical engineer to drive a car, is the promise of that. Okay, what is it? Internally, Hadoop is a framework. What is a framework? A framework is an engine. What is an engine? Inside the engine of a car, petrol is getting converted to electricity. So what is Hadoop doing? Hadoop is doing many complex things inside its framework. What does it do? It allows for distributed storage and processing. What does that mean? Well, back to our big data. Let's say here is 100 terabytes of data. Here's 100 terabytes of data. And now what do we have? Well, we have one server here. And what do we do? Well, we try to fit this 100 terabytes of data into this one. It doesn't. So what do you do? That's where what we'll do is we will use another server. Imagine this is server 2. Imagine this is server 3. And imagine this is server 4 and so on. Oops. Say choose this one. Choose this one. Choose this. Here's server 4. And let's say here's another server 5. And like that, you imagine hundreds of servers. Okay, what is that? Hadoop will take this 100 terabytes of data, it will distribute the data. How does it do? Well, imagine that's 100 terabytes of data. What it will do is, it will take the data and it is going to split that 100 terabytes into, let's say, 1 terabyte. And here is another terabyte. Oops, no time. Here's another terabyte. Here's another terabyte. Then what will it do? This is called splitting the data. It is taking your data, it is splitting the data. It will save it into each server. For the sake of simplicity, I'm saying it's 1 terabyte, but we'll get into the details in a moment. So now what is this? This is called distributing. What is it? That is what is, this process is what is referred as distributed storage. Not only is it splitting the data, distributing the data, but what does it do? It is also creating the backups. In other words, every time it splits the data and saves it in another computer, it will go ahead and make a backup of the data. It creates a backup here, then come here, create another backup here, another backup here. Then for another one, create a backup here and another backup here. So if you notice, for every one, there's a second backup and the third backup. Here is a second backup, third backup. Here's a second backup, third backup. This is called replication. What is it? This is also called storage. When you store, what is happening? Multiple events are happening. What is that? That is event synchronization. So what is all this? All these things were taken care of by the programmers. If you want to take this data and you want to split the data into store into multiple computers, what is happening is you need to understand what is multi-node communication. How do computers communicate? What is multi-process communication? What is multi-threading? What is, if one of the computers goes down, what do you do? Well, that is fault tolerance management. What do? You need to write code for all these things. So what's Hadoop doing? Hadoop is a framework that is doing all these things. For what? For large data or big data across clusters of commodity computers. In other words, what is cluster? Cluster is nothing but a group of computers is called as a cluster. Commodity computer means traditionally businesses were using very, very expensive servers. But Hadoop comes in and says, you don't need to use such expensive servers. You can use much cheaper servers. The cheaper servers are called commodity servers. And it gives us a simple programming model. That is where the hive, the pig, the scalar come to our rescue. Please give us some simple programming techniques which will help us in saving the data. Now, what is it? This is only the story. The bigger thing is the processing. What is processing? Processing is the super complexity. Storing itself is very, very complex, but processing is super complex. In other words, what is that? That is called distributed processing. What is distributed processing? If distributed storage is like saying you need to be a mechanical engineer to drive a car, distributed processing is super complex, which means it's like saying you need to be a rocket scientist to drive a car. Mechanical engineering itself is difficult, and so rocket scientists will be super difficult, which will be even more. So what do? That is what Hadoop does for us. It is open source, means it is free. It takes care of the data management. What is it? Hadoop is taking care of everything that we have discussed so far. With scale out storage. What is scale out? We'll try to understand. What is it doing? It is helping us accomplish the distributed processing. In other words, it comes to us and says, hey, you don't have to be a mechanical engineer or a rocket scientist to drive a car. You leave that. What do? To drive a car, turn the key. Don't worry about mechanical engineering. Don't worry about the rocket science, which are the complex concepts which are happening inside. What is it? It is hiding them from you. What is that? That's the framework. A framework hides all the complexities from you. Everybody catching the point, guys? Quick yes, please. Cool. So let's say, click on the, if you guys are logging into this one, just go ahead and try to log into this one. And let's see, the view lab comes up. Okay, labs are coming up. Now what we'll do is, let's get into view cloud manager portal, or let's say, let me just get back into web shell and see if Hadoop is installed here. Pause my screen. Let me just check my password here. Okay. User one. Okay, looks like I'm logged in. I'll share my screen. Okay. Let me just type in Hadoop. First one. Okay, looks like Hadoop is already installed here. Back to your login prompt and things like that. Hadoop is already installed here, guys. You can just get in there. We'll dig a little bit deep into it. So let's dig a little bit more deep into the theoretical aspects of Hadoop. One moment, guys. Sorry about that. Sorry about that, guys. Okay, so let's dig a little bit deep into Hadoop, and here is what is going on, guys. Okay, so what is Hadoop? Hadoop is a distributed file system. It stands for DFS. So let's say, come back here, snap it here. And what is a distributed file system, guys? A distributed file system is a group of computers. That can be 10, that can be 100, that can be 1,000 machines. Together, they all act like a single computer. What is that? That is a distributed file system. What is the advantage of distributed file system is, imagine there is 1 terabyte of data. And let's say we're unable to fit it on a single computer. What do? We generally use a group of computers. But let us say we're able to fit it on a single computer. We're able to store it on a single computer. And let's say that computer or the server has 4 channels. Let's say that is maybe hard drives. And maybe the rate at which the data we can read or write is, let's say, 100 megabytes per second. So what is that? With a single computer or single server, let us say it takes 43 minutes. The advantage of Hadoop is if we have Hadoop installed on 10 different computers, if we have that framework installed on 10 different computers, we can do the same process of reading the data in 4.3 minutes. In other words, what would take 43 minutes has been now reduced to 4.3 minutes by using Hadoop. What is it? Reading a file is very simple operation compared to the other complexities of mathematical operations which happen in machine learning and other kinds of domains, guys. Okay, what is that? A simple operation has been reduced by using 10 machines. We have brought it down to 4.3. What is that? That is a distributed file system. What is a distributed file system? It's a group of computers. They're acting like a single computer. So what is Hadoop doing? Hadoop, you may have 10, 100 or 1,000 or 10,000 machines. To you, as a user, it makes it look like it's one computer. What is the advantage of one computer? The advantage of one computer is it is simple and easy to work with one computer. Even if there are 2 machines, what happens? You have to be a mechanical engineer or rocket science without Hadoop. You have to learn many complex concepts. Okay, to work with Hadoop and to learn Hadoop is what it is, guys. Okay, so that is what is distributed file system. Everybody with me? Quick yes, please. Okay, let's go a little bit deep and try to understand how Hadoop works. What Hadoop does is, Hadoop takes the big data. The first step it does is it breaks them into small pieces. In other words, let's say, okay, imagine here is, let's say, server 1. And let's put this here. Here's server 1. Let's say this is server 2, server 3, server 4, and let's say another server 5. And what do we have? We have our big data. So here is our big data. This is generally very, very huge amount of data. So let's say for the sake of simplicity, it is, let's say, for the sake of simplicity, we'll start with maybe 100 MB. It's only 100 megabytes in file size. What Hadoop does is, it will take this 100 MB, split it into 64 MB, and then maybe let's say about 36 megabytes of data. Then what does it do? This is called splitting the data. It will take, whether it is 100 megabytes or 100 terabytes, it splits in the orders of 64 MB. Then it saves the data. This is called distributing. Okay. Then after it saves the data, what it does is it is replicating the data. So come here, which means make a backup here, backup 1, backup 2. By default, for every bit or piece or split of data, it is making another backup, 2 additional backups. By default, the replication factor is 3. Okay, and what else is there? So that is what it is. Imagine a file has been split into 4 blocks. File is being split into 4 blocks. What is happening is each block is saved into one computer. This is called distributing. First step is splitting. Second step is distributing. The third step. So what can happen in the world of commodity computers, which are generally cheap servers, is the server can fail. If the server fails, what can happen is the data on the server can be lost. In a professional world, that is not acceptable. What do? That's why Hadoop is making a replica. It is making a backup of every split. The split is called block in the world of big data. So what happens if a particular server goes down, we're still able to retrieve the data from other servers. This is called protecting the data. This is called fault tolerance. Everybody with me, guys. If this server goes down, we can get block 2 from here, block 4 from here, or from here and here. Catching it, guys. Quick yes, please. This is called fault tolerance. So what do? What is Hadoop doing? Hadoop is, without Hadoop, what will we do? We will write code. Take the file, split it. What will you do? You write code to manage the failures. You write code to break it into computation into pieces. You write code for scaling. And what's happening now? With Hadoop, you don't have to write many complexities there. Complexities like this. It is automatically taking care of it. And more importantly, it allows us to write scale-free programs. What scale-free program means? Imagine we have a server, and let's say there is 1 GB of data. Let's choose this one. Come here. Let's say this is 1 GB of data. And we have 1 GB of data we're processing. Now let's say we process the data. It's taking about 10 hours or whatever it is. Now let's say your client is happy about the results you got. And what will they do? They imagine now they're going to give you huge amounts of data. Let's choose this one. They're giving you huge amounts of data. Now, what will happen is, as the size of the data increases, what will happen? You will take the data, you will split the data into many servers, you will save it. Okay, but the code that you write on this 1 GB of data, without even a single code change, will work on even 100 terabytes of data. That is called scale-free programming. In other words, the code you write is independent of the size of the data. That is called scale-free programming. Everybody with me, guys? Quick yes, please. Okay, so that's a very big one for those people who have written for experienced programmers. Writing that kind of code is very difficult, even for experienced programmers. And saving all that kind of thing is a very big thing. That's why Hadoop has become so popular, guys. Okay, now back to understanding the replication of it. Going a little bit deep, here is what is happening. Okay, so let's say here is a cluster. What is a cluster? A cluster, think of these things as racks. Pardon me, sorry about that. These racks are nothing but physical boxes and things like that, which are where you can plug in the CPUs. So these are the CPUs which are acting like the servers. Server 1, server 2, server 3, and so on. What is a rack? A rack is a group of servers. A group of racks, pardon me, is called a cluster. Now what happens, the way Hadoop works is, think of this whole thing as one file. Think of this whole thing as one file. So I come here. So what happens is, it will take a file, it will split the data. After it splits the data, it will take that file and save it on the first split on the server. This is called a block. Remember, the split is called a block. Then what it does is, it will make a backup of them. Then it will take the second block, save it on the server, and it will make a backup. Then take the third one and save it on 2 other servers. So in other words, roughly, we visualize for a moment, every block that it is saving, let's say it is going to make a couple of blocks of the green ones here. So what is it doing? The first block, it will save in one server, in one rack to be more precise. The two other blocks are being saved in another rack. The reason is, imagine it has saved all the three in this rack. What can happen is, if this server fails, then you can get it from this one or this one. But if this complete rack fails, then we are at a total loss of the complete data. So by putting at least one in a different rack, if this rack fails, we still have a chance or a possibility of getting the data from another rack. So it is minimizing. That way it is slightly minimizing the chances. Yes, we can increase the backups, we can decrease the backups, we can change the racks. These are generally done by the admins when we don't really go to that level. But this is by default how the Hadoop is saving in different servers and in different racks. Everybody with me, guys? Quick yes, please. Okay. Okay. So next one comes a slightly more important topic or a concept, which is referred as data locality. At a slightly definition level, we say we are taking the processing to the data. In other words, let's say, back to the previous one. If you notice here, this is the process of splitting, distributing, and replicating. One moment, guys. Sorry about that. Okay, I'm extremely sorry about that, guys. Can you give me a quick yes if you guys are there, if you guys are back? Okay, one more time, apologies. A few interruptions, please expect today, guys. Sorry about that again. So here is what is going on, guys. Imagine, for the sake of simplicity, this is your laptop. We have a file here. This is a file, and let's say it's inside a laptop or a server. The first thing that we do is you tell Hadoop, hey, here is my file. And let's say this is a group of, this is a cluster at a slightly high level. We'll call it cluster. We'll try to discuss about a cluster in a moment. And what we do is, here is the file. So what Hadoop does is it will take the file, it is splitting it into 3 parts. For the sake of simplicity, let us say it is 150 megabytes. So the 150 megabytes is split into, so come here. A little bit of cough, guys. So there is, let's say, this is going to be, let's choose red one here. Here's a 64 megabyte, it's split into 64 MB. Then the next part, it's split into 36, 64, another one will be 64 MB. And another one, it's split into 128 plus, I think this will be 22 megabytes. So 150 MB file, it's split it into 3 parts. And now what it is doing is it is saving the first 64 MB here, the second one here, and you just visualize it is replicating. The other 2 parts is where it is automatically replicating for the sake of simplicity. This is the process of storage. This is what is called distributed storage. The next thing that will happen is we will write some kind of programs. This could be a simple Python program or a very complex machine learning algorithm written in Python. So let's say, before we go there, let's say come here. Here is, let's say, a data scientist or a data engineer. What they're doing is they want to run some analytics on this file. So ideally what they'll do is they'll write a program. One more time, just one moment, guys. Sorry about that. Okay, sorry about that, guys. So imagine that's a data engineer, data scientist. He has given the file, he has saved the file from the server. The file has been, oops. Sorry about that, guys. This is the process of splitting, distributing, and replicating. Now, what will happen is we will write a program. The program can be a simple Python program or a Hive or a Pig program, or it could be a very complex machine learning algorithm or a deep learning algorithm. What will happen is when we write a program in Hadoop, what Hadoop will do is it will take the program and it will move the code to the place. It is deploying the code to the place where the data is there. Your first 3 parts of the data. Together, the red part, the green, the blue part, and the green part together is our data. So now what we say is the code is moving from our laptop to different servers. This is where we say the data is sitting and the code is moving. Okay, data is sitting means data is not moving. Data is local. What is that? That is called data locality. It is referred as one of the fundamental design principles, or it is a very, very important principle where the process. Traditionally, what happens is it is the data. If you are slightly familiar with entire architectures, which I don't expect because you guys are in much earlier stages, traditionally what will happen is you have different servers. There's a, let's say, UI layer, business layer, I'll give that blue. There's a data layer, let's say give it a green. And let's say here's a database. Say choose this one. Is a data layer. And traditionally what happens is data, let's choose this one as data. There is some data in the database. What happens is, let's say here's a web application. This is a web application. So I choose this one. Let's say this one. Here's a user who's using a web application. When you use a web application, traditional applications, what happens is behind the scenes, the web application goes to your business layer. The business layer goes to your data layer. The data layer goes to your data database and gets the data. From here, it gets it here. From here, it gets it here. The data is being returned from one server to another server, and the data is being displayed. This is a scenario traditionally where data is said to be moving, code is sitting. In each of these servers, code is sitting, but the data is being filtered and moved around. Okay, this is where data is moving. But in the world of big data, because the size of the data is generally very, very big, 150 terabytes, 150 petabytes, we cannot move that amount of data within the network. The entire network will get blocked. So what did they do? They intelligently, they reverse the scenario where they are moving the code to the place where the data is. They keep the data is moved only at the time of loading the data. After the data is moved, it is the code which moves to the different servers. What is this? This is called as data locality. It is taking the processing to the data. What is taking the processing to the data? The processing is the code. And what happens when the code moves? It is going to run. Let's say, come here. It will run. At the time it runs here, it will also run on this part of the data and this part of the data in parallel. So what is this? This is called parallel processing. So what does that mean? The parallel processing also, what was happening? We were writing the code. As before Hadoop, before the world of Hadoop, we were writing the code. But because of Hadoop today, we don't have to learn the parallel processing and many other complex things. What is it? That is called data locality. Everybody with me, guys. Quick yes, please. So let's dig a little bit deep into some of the characteristics of Hadoop. Okay. So why Hadoop? It is accessible. Hadoop runs on large clusters of commodity machines. What is important for businesses is a business is always trying to save money. Imagine Pravalika is going from her home to work and work to home. Imagine you ask her to buy a Ferrari car and go from home to work or work to home. What is the problem? Well, it's expensive. It's very, very expensive. Okay, what is happening? A business is a business when they are looking at traditional servers are enterprise class servers. They're very expensive. Okay, and what is happening? They're very expensive is one of the main problems. So that is where Hadoop comes in and tells you the first thing. If you want to go from home to work or work to home, don't buy Ferraris. You have Ola and you have Uber. What are they? They are like cheap transports. So in other words, much less expensive, cheap transports. What is that? They are like commodity. Okay, you don't have to pay a lot of money. That is what is commodity servers, which are nothing but cheap servers. There are going to be some differences. We'll discuss about them. And cloud makes it even more cheaper. That is what we mean by it is accessible. It is robust. It is architected with the assumption of frequent hardware malfunctions. What it means is the commodity machines can fail at any time. The problem with commodity machines or computers is they do not give you guarantee. They can fail. Enterprise class servers, they give you guarantee. Whereas the commodity servers, they don't give you guarantee, but they're cheap. So what can happen? They can fail anytime. So what will happen? Hadoop, even if the servers fail, it will gracefully handle the failures. In other words, if one server is lost, it will get the data from another server and return the data. What is it? That is what is replication. So in other words, it is handling the failure. Scalable. If you write the code on small amount of data, and if it works on 1 GB of data or 1 MB of data, even if you increase the size of the data such that it fits on 100, 1000 or 10,000 computers without even a single line of code change, the same code will work on the data wave, which is 100 terabytes of data. What is that? Even if the number of servers increase, what is that? That is what is scalability. In the coming up days, I will talk a little bit more in detail about scalability in the world of cloud computing. I will give you more idea, guys. Okay. Sorry about that, guys. Okay. So what is scalable, guys? If you, let's say, have one server, and let's say you suddenly increase it to hundreds and thousands of servers, what is happening? Hadoop will work without any problem. No matter you add 10, 100 or 1000 or 10,000 servers, not even a single line of code change is required. That's what is Hadoop. So it is very scalable. It is simple. Simple means it gives a simple programmable way of working using tools such as Hive, Big, and Python. What you will take some complex code in Java, we can write very, very simple lines of code in Hive, Big, and Python, and we can work with big amounts of data, with big data. The parallel processing and many other complex things are automatically taken care and handled by her. And at a fundamental level, it uses the principles of data locality. It is moving the code to the data. What was happening? You needed to write code to handle the scenario, and it is complex. That is taken care of by her. It is also replicating the data. In other words, we don't have to write the code. All these things we were writing the code, which Hadoop is automatically taking care. Those are fundamental characteristics of Hadoop. Everybody with me, guys. Quick yes, please. Okay, moving a little ahead. Let's see, what do we have? Snippet. So they are drivers. So what is happening? This is from a technical standpoint, but from a management standpoint, from a business standpoint, what is happening is for a business, bigger the data, higher the value. Everybody is after bigger data. Why everybody is after bigger data? Big data, because the more the data we have, the more the value. If you go back to the example of Revati, when we looked at the psychographic insights, what is special about psychographic insights, guys? Imagine if you're able to find 100 customers who, who like Reebok versus a million customers who like a Reebok, well, what is that? When you have more customers' insights, what is that? That is more value. And every business today is after. They are going to the internet, they are browsing the website, scraping the data, trying to find different kinds of insights, not only about a person, but about the products, about real estate, about anything and everything. That is what the analytics startups are doing. That's where they're coming across with big data, and that's where they need the big data engineers, the data engineers, the data analysts, the data scientists. It's what is happening. So the more the data, the more the value in the data. That's what is important for the business. Financial drivers, cost advantages of open source. Hadoop is free. It uses cheap servers. We don't need to use very expensive servers. You don't have to buy a Ferrari car to go from home to work and work to home. You can buy cheap. You can just go by Ola and Uber. You don't need to buy a car. what do? You rent, you pay, you just pay the rent and you use it. So what happens? The cost is being reduced. Technical drivers, the volume, velocity, and veracity, which variety is what we'll do. The complexity of is also decreasing. As the data increases, traditionally what was happening in businesses is the complexity is increasing. The businesses were not able to work. But because of Hadoop today, the complexity has decreased, is what is happening. Everybody with me, guys. Quick yes, please. Okay. So a little bit, going a little bit deep into the depths of it. Let's see. Traditional databases. So here is traditional databases. Data warehouse and enterprise data warehouses is this one. These are bigger databases. If you have more data, businesses will use enterprise data warehouse. And if you have even bigger data, they will use massively parallel processing and analytics, which is generally run on enterprise data warehouse. If your data further increases, then we use NoSQL, HBase, the MongoDBs, and things like that. Then that's where it comes if you have even bigger data coming into the Hadoop, into the world of Hadoop. So in other words, traditionally what was happening was the traditional databases is schema is required on write. Okay, what it means is if you want to save some data into the database, then what you need to do is you need to know the schema. Schema means you need to know the table, the database name, the metadata, the column names, the data types, the relationships required to save the data. Schema is required on write. Okay, in a NoSQL or more precisely in a Hadoop world, it is required at the time of reading. In other words, you can save any kind of data. In traditional database, you can only save structured data. In Hadoop world, you can save structured data. You can also save unstructured data. Then once you store any kind of data, what you do is you try to read the data. That is when you say you need the schema. In other words, this depends on the use case. In other words, in traditional database, one of the problems is you cannot store unstructured data. That is the problem that Hadoop is solving. It will, if you have data, no matter what kind of data, you can just store it. That is what this one is about. Reads are fast. Reading the data is fast. But if you're not able to store all the data and you try to read it, then you're losing some very important data. Here, writes are fast. Okay, so writes are fast, which means, so in other words, saving the data can be done at a much faster speed than reading the data. Reading the data in the world of big data, reading the data can be a little bit slow. And these are slightly advanced concepts, guys, which you'll probably understand a little later. So for the sake of academic discipline, I'll talk about these things as what it is. So in the world of big data, even if you're reading a little bit slow because the size of the data is very big, your users will not complain. If you have 10 or 100 terabytes of data and you say, hey, it'll take 1 hour for us to process this amount of data to generate a report, they will be generally okay. So reading, if it is slow, it is okay, but loading is generally fast here. Governance, only structured data can be stored in a database, whereas here you can store any kind of data. It is loosely structured. And in database, there is limited amount of data that you can store. Okay, the more the data, more the cost. Whereas here, there is no limit to the data. And processing is coupled with the data is nothing but the data locality. It will take care of how to work with the code and the data. Structured data, again, more precisely, it's all about structured data, which is the rivers of the world. Here it is unstructured. The seas and oceans of the world can be stored here. Okay, generally database data, enterprise data warehouse is useful for doing analytics, which with a limited amount of data. That is OLAP, online analytical processing. Okay, and if you just want to read, modify, update, and delete, that's what the database data is for. Whereas in the world of Hadoop, you use the data for discovering hidden patterns in the data, for processing unstructured data. You want to find the insights in the data. Okay, and then massive data. You store massive data, you process massive data. Generally, businesses were not doing. That is what the Hadoop will help you. Everybody with me, guys. Quick yes, please. Boom. Okay. So moving on to the next one. So, snap it. Okay. Big
Lunch
data.
break.
Storage management, Hadoop distributed file system, and cloud era manager. So cloud era manager is what we'll see in coming up days. Our Hadoop distributed file system is what will work. It is nothing but a group of Linux commands. Until now, the Linux commands that we have looked at, we have worked with. What are they? They are generally run on a single computer. But in Hadoop, Hadoop is a distributed file system. When you run a single Linux command, what it does is it is doing the work on multiple computers. How does that happen? We'll try to understand that. That is the storage part of it. In the database, we use Hive and HBase. What are these used for? These are used for storing the data in the form of a database. Not only can we store the data in the form of unstructured data in Hadoop, we can also store it in the structured data using Hive and HBase. Okay, map reducing is the super complexity. In other words, MapReduce is where the computing part of it is. It is the processing part of it. This is the rocket science part of it. This is what is the technology of big data for processing the data. It is the heart. MapReduce is the heart of Hadoop. Is what it is, guys. Okay. Data integration is for connecting Hadoop with other kinds of databases and things like that. We can use R. We can use Python. Today, Python is getting more popular than anything else. That is why we are focusing more on Python to work with big data and things like that. These are some of the technologies that we'll be looking into in the coming up days, guys. Okay. Okay. So here are a few more tools. Maybe after this one, we can take a short break and regroup again. Okay. So many related tools integrate with Hadoop. So we can think, say, come here. Think of this. Here is server 1, here is server 2, server 3, and you imagine a lot of servers there. So what is Hadoop? You can think of Hadoop as a single file system. It's like a single file system. It is sitting on a group of computers. It is sitting on a group of computers and it makes it look like single computer. So what is this? This is referred as HDFS. You can think of this as the brain of Hadoop. What happens? This is where the data is getting stored. Different kinds of data is getting stored. So let's say the data can be structured data or unstructured data. So here is different kinds of data. Visualize in a moment. This is some data, and here is more data. You store different kinds of data in different varieties, is what it is. Now, we call HDFS as the brain. In our brain, we store different kinds of thoughts. Okay, then what do? That's where the MapReduce comes into the picture. Let's say use this one. The MapReduce sits on top of HDFS. Which is this one. The MapReduce can be thought of as the heart of Hadoop. Okay, this is MapReduce. What is MapReduce? MapReduce is the heart. Why? Using our heart, visualize for a moment. We go to our brain, we read our thoughts, we analyze the thoughts in the brain, and then we take decisions. In other words, MapReduce is used for analyzing the data. HDFS. So in other words, more precisely, choose this one. Together, these two. Hadoop is generally HDFS plus MapReduce. Let's give this a brain. Together, these two are referred as the Hadoop. What is it? It is the brain and the heart. The brain is the distributed file storage. MapReduce is the heart of it. Okay, so what is this? That is what is Hadoop. And now here is Hive. Let's start, let's say use this one. Say use, okay, this one. Here is one of the eyes of Hadoop. This is Hive. Okay. So what is Hive? Hive is a simple tool which will take SQL-like commands as input. It will take SQL-like commands as input, and it will internally communicate with MapReduce. In other words, when we look at something, let's say we're looking at Reebok or Nike shoes and we are making a decision which one is a good thing. Imagine what we are doing is we are using the eyes and making a decision. What are eyes doing? Eyes are internally connecting with the heart. Heart is internally connecting with the brain. So what is it? Hive is one of the eyes. Okay, it is much more. MapReduce is a very complex way. We have to write some very complex Java MapReduce programs to analyze the data. Hive is a simple way. What does it do? It will take simple SQL-like commands. It will take simple SQL-like commands as input, and it will internally convert them to Java MapReduce programs. Then another I of Hadoop is, let's say I choose this one. Let's say this one is pig. Let's say choose this pig or Apache pig. Choose this. Choose this one. Here is Apache pig. And what does pig do? Pig is also similar to Hive. It will take simple English-like commands as input. It will take simple English-like commands as input. It will internally convert them to Java MapReduce programs. These are the ones we'll try to understand in the coming up days, guys. Okay, it will convert them to Java MapReduce programs, and it will internally analyze the data and give us the results. Is what. So that is Hive and Pig. Yes, Hive and Pig. These are the two eyes. Scoop is a data integration tool. It is used for connecting Hadoop to any other databases. This also will try to, if time permits, we'll try to dig deeper into this one. So choose this one. This is Scoop. Then Uzi is a workflow manager. It's used for connecting different workflow steps. When you have different steps, it's used for piping. The output of the step one should become input to a step two, and so on. Mahout is a machine learning tool of Hadoop written in Java. But today, more than Mahout, Python is used more in a real world, guys. More than Mahout. Mahout has slightly become outdated today. Everybody's after Python's libraries. And Cloudera Manager is the admin tool. Let's say use this one. This also will try to look and understand, mostly used by the admins to manage the process, servers, and performance measures and things like that. Together, all these things are referred as the Hadoop ecosystems. Generally, when you work with Hadoop, you are coming across these terms. The most important thing is Hive and Pig, followed by Scoop, bit of MapReduce, and a bit of HDFS, and Spark. Then comes Spark. Spark is also, let's say, use this one, use this one, comes here. It is a much more, it's another eye. It has become another eye. Spark with Python, PySpark, and Scala. Let's say put this here. PySpark. And this has become another eye. This has become a faster eye. This is much more. This is 100 times faster than Hive, Pig, and Hadoop. What will it do? It is also internally working with the HDFS using MapReduce. It will also internally analyze the data, the big data, and that's what we'll try to learn in the coming up days, guys. These are different tools that we generally come across and work with in the world of big data. We'll try to get familiar with these things and so on, guys. Everybody with me? Quick yes, please. Cool. Okay. So before I move on to the next topic, which is where with a little bit of labs is starting, let's take a short break and we'll come back. So roughly by 2:15, we'll regroup and we'll continue the journey from here, guys. Everybody okay with that? Okay. So we'll stop it here and we'll regroup again, guys. Okay.
కాల్ పాడైపోతాయి అబ్బాయి షూట్ అబ్బాయి మీరు వచ్చిన పిల్లలు బయలు
చెప్తే
Sai Vidya, can you make me the host, please? Vidya, can you make me the host, please? Vidya, are you back? Could you make me the host?
Really good stuff.
Okay, great, thank you. System. Okay, just rearranging the slides, guys. Just give me 1 moment. Sorry about that. Okay, sharing the screen. So share it. Okay. So guys, can you give me a quick yes if you're back? Thank you, Savidya. Thank you, Pratyusha. Give me 1 minute. Okay. So here we are. Okay. So what we'll do, we'll access the web shell and store clear. If you're with me, just go ahead and type in clear on the web shell guys. Just try to follow a few commands here. So, okay. Everybody with me guys, quick yes please. Could you, okay, if you're accessing web shell today, I'll go ahead and type in a few comments, then later I'll ask some of you to type in the comments. So here's the first question, first command, Hadoop version. These are nothing but the Hadoop commands which are similar to the Linux commands, okay? And they will be, you'll notice a lot of similarities. The only thing is when Hadoop runs, it runs on group of computers. How does it run? That's what we'll try to understand. Okay, Hadoop version, it determines which Hadoop version you're using as well as checksum and dates. It also shows when the release was built and by whom. So in other words, let's say, try this one. First thing you may want to do is to verify, just type in Hadoop. You should see something like this coming up. It gives you information. So this is where I typed in Hadoop and usage of Hadoop. It says build paths to and things like this. So it gives all the possible commands and so on. Imagine, so clear will clear the screen. Okay, guys, the first one, you can run with me. Here is the first one, Hadoop. Then I did a clear. And back here. So the first one is Hadoop, then clear. And the next one I'm going to type is Hadoop version. Hadoop commands, say, save it. So back to shell, type in Hadoop version. Control Shift V is working this. Type in that one, Hadoop version. So it's right now running Hadoop 3.0.2, and the rest of it is more of a your FII. You really don't need to worry about the source code at this stage. Jenkins, again, you don't need to worry. So here, we have an idea and be familiar with what we are running Hadoop version 3.0.2. That's what we are using. That's okay. Pardon me. Sorry about that. Let's see what else we have. So we'll go one step deep and try to understand Hadoop FS MKDIR. If you recall, MKDIR is nothing but it creates a single directory. It creates a directory. It's used for creating a directory in Hadoop, guys, in Linux. Okay, the same thing. The only thing is we are saying Hadoop FS. Hadoop FS means you're not talking to the Linux computer, you're talking to the group of computers. And let's say MKDR D1, D2. Okay. So the same thing. Okay, come here. Say snap this one. Imagine, for the sake of simplicity, let's say this is a Linux computer. And let's say here is a group of servers. Okay, if you recall, let's go ahead and put this. This is, oops. This Hadoop. This is HDFS. This is HDFS. Okay, these are 4 computers. So generally HDFS is acting like a layer on top of it. It acts like a group of computers. It acts like a single computer, but behind the scenes, it's a group of computers. Okay. So in other words, back here, this is like a single Linux computer or server. Okay, so when we say mkdir, say P1 here, what's happening is single Linux computer. It's creating, for sake of simplicity, it's creating a directory here. One moment, sorry about that. Sorry about that, guys. Just bear with me for today. Too many things going on. So if you recall, guys, when we do make directory in Linux machine, what is happening is we're creating a directory here. Can everybody recall that, guys? Mkdir command. We briefly discussed, we spent some time. Okay. Now what we're going to do is when we say in Hadoop F mkdir, for Hadoop, what we will do is choose this one. It is the same command, but so choose this, put this here. Hadoop fs mkdir. We'll say d1. So what is going to happen is at a slightly high level, we issue this command in Hadoop. And for the sake of understanding, let's say it creates a directory here. What is this? This is actually directory. Behind the scenes, what is happening in Hadoop is it may actually create the directory here, here, or here, or here, which is we don't need to worry. That's what is Hadoop. What Hadoop does internally, you don't need to worry. Okay, so in other words, let's say it may actually create it here or in any other of them. But it looks like, but what does it show? This is what it shows to us. It says, hey, the directory is created. Here is what it shows. So now, let's see back here, version back to this one. So now, let's say if you recall PWD, present working directory. So next one, verify present working directory. ls-ltr is going to be the next command. ls-ltr. So notice tm00 basics, that was the last one I have created. Now what we'll do, and it looks like, notice all of them are starting with hyphen, so we don't have any directories. So we'll say mkdir, we'll say d1, ls-ltr. Notice d1 is created, that's the latest one which is created, okay? So what did we do? mkdir d1, we'll say ls-ltr. So this is creating the directory. We verified it's creating in Linux. Now, what we'll do, say Hadoop fs-ls and press enter. Give it a moment. So this is communicating. So in other words, I'm gonna copy this one, paste it here. Oops. We should say fs-ls. We did not notice, we didn't get anything. But now what we'll do, we'll say Hadoop fs-mkdir, we'll say D1 directory 1 underscore HTTP. Okay, so let's say if we come back here, we're saying dir1 here in the file, we'll say d1 underscore HTTP. Copy this one. And I'll execute this here. Run it. Oops. Run it. And let's see. Now, what we'll do, bring up the previous command, Hadoop FSLS, and notice you will see a directory d1 underscore HTTP. Notice it's a directory. Okay, what is this? When you say Hadoop FS, guys, what is happening is we are communicating to the Hadoop distributed file system. We are not communicating with the Linux directly. We are communicating with the first floor. These are all the ground floors. Hadoop is your first floor. What is special about the first floor is, think of all the ground floors as ground floor apartments. Think of the first floor as one apartment. In this one apartment, there are no walls. It's only one apartment, but behind the scenes, it is a group of apartments. Okay, so I'll simplify that again in a moment. Let's come back here. So now what did we do? After I created this, I have checked again. When you say ls, okay, back to Linux, if you say ls, notice, it'll give you a list of files and directories. Everybody with me? Quick yes, please. If you say ls, it is giving you this one, right? But okay, so you type ls. But when you say Hadoop FSLS, what you're asking is, you're asking Hadoop, give me a list of files in your first floor. When you say Hadoop FS, you're talking to the first floor. When you say only ls, you're talking to the ground floor, is what it is. When you talk to the ground floor, you have to talk to each apartment guy and say, hey, what are the resources inside you? What are the resources? Well, your sofas, your chairs, your beds, your other TVs and things like that are nothing but the different kinds of files and directories. They are the resources. That is what it is like. That is what we need to keep in mind. That is what we need to understand. So if we come back here, Hadoop FSLS, you're talking to the first floor, not to the ground floor. Give me a list of all your files, and notice what it gave us is, it says, hey, there's a directory called d1 underscore Hadoop. Now again, one more time, when you do an ls, right, what you're observing is, notice you don't see a d1 underscore LDP, ls hyphen LTR. It shows d1 as the latest. Okay, one more time. We did that. One more time, I'm doing ls. One more time, I'm typing ls hyphen LTR. And what we are noticing is, we are no longer seeing d1 underscore HD. So in other words, if you come back here, let me see if I can simplify this one, guys. Let me, for the sake of simplicity, let's take this one. Think of directory like a chair. Okay, let's say come back here. You can create with, you can create with same names also. So here is, let's say, a chair. When you create, let's say this is a ground floor apartments. Let's say you created a chair, or you put a chair in the ground floor apartment. When you say ls, it will show you the chair. But in Hadoop, when you put a chair, you're putting a chair in the first floor. Okay, when you put a chair in the first floor, behind the scenes, it can go anywhere. Leave that to Hadoop. You don't even have to worry about it. Behind the scenes, this Hadoop, this first floor is like a virtual layer. It is not there, but it looks like it is there. That is what is the magic of Hadoop. So when you say, give me a list, okay, what it will do, it will give you the chair. But but if you go and look here, either in either of these computers individually, you will not find it right away. It is storing somewhere hidden. Hadoop does that purposefully. It stores somewhere. It doesn't want us to know where it is. That is again taken care of by the admins and things like that, guys. Okay. So when you created a directory, imagine we created a directory called chair. Okay. Let's see. Okay. So let's see. One more. We'll give one more try. Okay. Come here. We'll say Hadoop. We'll say back to mkdir. We'll say here is APT, apartment 1. Okay, so now take a look at this. mkdir back here. ls-ltr. D1 is latest one. Okay, then we'll say KDR apartment 1. Again, verify ls-ltr. There is apartment 1. Okay, there is apartment 1. Again, we're verifying ls-ltr. Okay, are you all typing along with me, guys? Quick yes, please. If you type along with me step by step, it will also be a good exercise for you. Are you able to type it, guys? Quick yes, please. Give it a try, guys. It will be helpful for you. If we do, as we increase the complexity, if you're typing with me, you will be able to, you'll be going to the next level, guys. So we created apartment 1. In other words, let's say, for the sake of simplicity, this is the Linux directory. For the sake of simplicity, let's come here. Do a little bit of cleanup here. mkdir, say, apt1 in apartment 1. So we'll say come here. So let's say this is apartment 1. This is a directory for the sake of simplicity. Now let's say, next we'll say cd apt1. Okay, so come back to Linux, say cd apt1. I'll clear this one. Oops, pardon me, one moment. Sorry about that, guys. So I cleared it. We created an apartment. One more time, we'll verify ls-ltr. Sorry, we are right now on pwd apt1. So back here, we did cd apt1. Then again, we'll verify ls-ltr. So this is like a new apartment we just created. This apartment, there are no files. Files are like chairs and sofas is what we'll assume. Okay. Now, if you recall, we'll say, come back here, say touch chair1.txt ls-ltr, and I'll run these two at one time. I'll try to run these two at one time. Okay. I'll say ls-ltr. There it is. So if you say pwd, we're in this directory ls. Oh boy. Okay, extremely sorry about that, guys. Okay, so there is chair 1, guys. So it is like, if we come back here, this is our apartment 1, this folder. In this apartment 1, let's assume, so we'll say this is the apartment 1. In apartment 1, let's say choose this one. We have created a chair 1. We'll say this is chair 1. So chair 1, the green chair is inside the blue apartment, is inside the pink building, is what we'll say. Now back to HDFS. We'll repeat the same process, which means we'll try to apartment 1. Okay, here we'll say Hadoop fs -mkdir. Hadoop fs means you're communicating it with the first floor. So here we'll say we'll create a directory So in the first floor, let us say, what should we do? Chair1.txt. If I say mkdir apartment 1, okay, let me do this, guys. One more time, I'll repeat this process. I will not create this CD. We'll go back to the previous. So this is CD. We'll create here. So in other words, I'm currently in this directory and I will say CD verify pwd. Yes. So I'm back to my home directory. Now what I'll do, ls-ltr is apt1 is the latest one. Let's clear this one. Oops. Clear this one. One more time, pwd ls-ltr. Everybody with me so far? I'm back to my home directory. Can you give me a quick yes, please? I'm back to my home directory and I'm verifying. Earlier I created. So for the sake of simplicity, before I explain your slightly complex scenario, I'll explain your slightly simple scenario, which is, let me remove, say, rmdir apt, rmr. Let me do an rmr apt1. What is it? rm hyphen rf apt1. So that is recursive delete is what it is. So now if you say ls hyphen ltr, notice it's not clearing it properly. It's not painting it properly. Clear it. ls hyphen ltr. So D1 is the latest. So in other words, I removed this one. Now I'm going to redo this, which is I will say touch chair1 dot txt. And if you say ls hyphen ltr, notice, clear it. Notice chair1.txt is there. So what did we do? For the sake of simplicity, I'll come back here. I will not create the apartment. I will not create the mkdir, but if you recall touch is nothing but it is creating an empty file. 0 bytes. It's just an empty file. It's a way of creating empty files. Everybody with me? Quick yes, please. Okay, what did I do? Earlier we did a touch. So in other words, I came back here. You touch chair1.txt, you're verifying it. Now here also, I will not create a directory. I will say fs hyphen touch char chair1.txt. Chair1, let's say underscore h.txt, just so that we know it's a Hadoop file. And copy this one. Say clear this one. Paste it here, run it. Now notice it'll take a few seconds. Say Hadoop fs hyphen ls. Say come here. So now if you say Hadoop, oops, copy this one. After you touch it, paste it here, run it. Run it. Notice it says earlier we created d1 underscore HTTP, and now we created chair1 underscore h, which means what we just did is, if we go back here, we have also created a chair in here, the green chair here. This is creating a chair in this Linux computer. This is creating a chair in here. What is the chair? Chair, both of the chairs are nothing but the files. Okay, what I'm trying to convey is, for us, we don't really need to worry. It looks like this chair is here. Okay, let me get rid of this one. Let me get rid of this one. But behind the scenes, what happens is, oops, one more time. Okay, behind the scenes, this is actually maybe sitting here, here, or here, anywhere. But Hadoop makes it look like it is here. And that's all we need. We don't need to worry where it is really sitting there, unless for administrative purposes, and we probably don't even have to go that side, guys. Okay. Now let's see. That is Hadoop FS. Everybody with me, guys. Quick yes, please. So we did a touch there. What do you do in Linux also? The same thing we're doing in Hadoop. Nothing much. But I'm just giving you a pictorial idea so that more complex, we can look at more complex things in a moment. Now that is, we created a touch. Now again, for the sake of simplicity, we'll repeat this one. So let's say, we'll say mkdir, say room 1. We'll say room 2. mkdir means we're creating in Linux. Back to Linux. Okay, dir room 2. Verify ls-ltr. LTR. So there is room 2. So back here, you verified ls-ltr, you verified. Repeat the same thing, Hadoop fs-mkdir room 2 underscore h, so that we know it's a Hadoop file. And before we do this, we'll say, copy this, -ls. Give me a list of chairs and rooms. Chairs and rooms in your is what we'll ask. So we'll start with this one more time. Clear? FSLS. So right now we have chair1h d1 underscore Hadoop, which is the directory. Notice starts with the D here. Now Hadoop FSLS. Now next what we are doing is we'll say room 2 underscore h. Room 2 underscore h. Oops, sorry, we missed mkdir. Clear this. Say mkdir room 2 underscore h. Let's run it. Hadoop fsmk room 2 underscore h. Now, after we do that, one more time we'll verify Hadoop fs-ls. Okay, copy that. ls, oops, run it. Now notice room 2 underscore h has been created. It's a directory, chair1 underscore h dot txt. Okay, so now let's see what else we have, guys. So in other words, if we come back here, what we just did is, let's say for sake of simplicity, we'll say here is room. Let's take this one. We created a room. We'll call this as room 2. Here also, we'll say we created a room. Everybody with me, guys. Quick yes, please. Okay, now the next command is create multiple directories. fs-mkdir room 2, room 3, room 4. Okay, so in other words, just for the sake of discipline, we'll one more time repeat this. Where is it? mkdir room 2 we already created. Room 2, mkdir room 3, and say room 4, and say room 5. Copy this. Enter it. ls-ltr. So room 2, 543, 345 are created. How many duplicates will Hadoop create? Okay, hold on. So back here, if you are following me, list of commands again, ls-ltr. Now we'll say, just type in Hadoop fs-room 2 mkdir room 3 underscore h room 4 underscore h room 5 underscore h, and then Hadoop fs-ls is what we'll do. So first we'll run this one, clear this one, type in clear so that it's easy for you. Okay, so creating multiple directories, Hadoop fs-ls is here. If you verify now, room 2h, 3h, 4h, 5h are created, which means, for sake of simplicity, choose this room 2, so room 3, room 4, room 5 has been created here. Room 2, room 3, room 4, room 5 has been created here. So I'm using underscore h here to indicate this is a directory I'm creating in Hadoop. This is the directory I'm creating in Linux. It is not necessary. Every time you create a directory in Linux, in Hadoop, even if you use the same name, it is different. Just to make you understand, hey, this is a directory in Hadoop, I'm giving _h. I can just say room 5. But this room 5 will be different from this room 5. Are you understanding, Lokesh? When I say mkdir, back here, we are creating a directory within the ground floor. You're creating a room. Directory is like a room. You're creating it in the ground floor. But when you say Hadoop FS mkdir, what is Hadoop FS? Your first layer, your first floor apartment. Here you're creating in the first floor apartment. Here you're creating in the ground floor apartment. Okay, wait. I'm coming slowly to other commands. We'll see them. Is what it is. Are you catching, Lokesh? So we created one file, one chair, and 4 directories so far. And we are trying to kind of understand, hey, one is in the first floor and one is in the ground floor is what we are trying to understand, guys. This is mkdir. Okay, make directory, create parent directory, okay. So this is -p, mkdir parent p, and the parent dir, okay. So here we created dir1 -p, okay. Create multiple parent directories. So you create a parent directory and a child directory is what this is doing, ls -r. Okay. So in other words, now, let's say, this is mkdir-p. Here we just did mkdir. So create parent directory along with the parent directory. Okay, so in other words, let's say, come back here. Now, what we are doing is, we'll repeat this step. We'll repeat this step. We'll call this room 2, 2 underscore, let's say, A. Room 2 underscore 1. We have room 2 underscore h, but we do not have. Okay, then we'll also create another directory, room 2 underscore 1. And in that room, we'll create another room underscore 2 underscore 1 underscore 1 underscore h for the sake of simplicity. So room 2 underscore 1 pardon me. One moment, guys. Guys, a few personal things going on today at home. You have to bear with me. I may take a short break in a few minutes. Just giving you a heads up, guys. Sorry about that. Please bear with me one more time. Sorry about that. Give me one moment here. Okay, sorry about that, guys. So let's say I'm just trying to simplify this one. Room 2, rather than giving room 2, what I'll do, guys, let's say we'll call this as room underscore room underscore kitchen. We call this room underscore kitchen. Inside kitchen, we'll say we'll have copy this one. We'll have another room kitchen underscore h1 kitchen underscore 1, and let's say copy this underscore kitchen. So we do not have room underscore kitchen right now. We'll also have kitchen underscore 2, but the difference is right now we'll put -p. Okay, so in other words, to make you understand this one, let me run this one like this. Notice, we'll first run it without p. Without the option p, we already know we do not have room underscore kitchen h. And may come back here, make sure the syntax is correct. -p, so room underscore kitchen h, kitchen underscore 1, and we do not have kitchen underscore 2. So if we try to run this, I don't think it will create it. Let me run this one. Let me do a clear here. Paste this one. Run it. No such file or directory, if you notice. Okay, so now what we'll do, we'll come back here. We'll give it -p, which means even if the parent directory is not there, let's run it. And let's say now, notice it didn't give us any problem. So if you now say Hadoop fs -ls, notice room underscore kitchen is created. Okay, so let's type verify that Hadoop fs -ls. We verified this. Now what we'll do, say -ls space room underscore kitchen. What will give? No such file or directory. Oh, so kitchen underscore h. So there is kitchen 1 and kitchen 2. Underscore h is what I forgot. So we are observing. So what -p does is, even if the parent directory is not there, it is creating the parent directory and creating the directory. Pardon me, are you catching it, guys? In other words, if we come back here, what we just did is, here is a parent directory. Under that, I created 2 directories. Pardon me. Like that. That is option -p. Okay. Okay, guys, one more time. Can you give me a quick yes, please? Okay. Okay. Next, come back here. Parent directory. Now, that is the second one. Let's go to the next step, which is ls and ls-r. Okay. Here's a slightly important one. Back here. Notice when we do -ls, still clear. Clear it. Paste it. Enter it. You're now asking Hadoop, hey, what are all the files and directories here? When you say ls, say ls, come here. What Hadoop is doing is, it is telling you, I have one chair, I have one blue room, I have 3 pink rooms, pink room 1, pink room 2, pink room 3. I have another orange room is what it is telling, but notice it doesn't give you. One moment, guys. Okay, guys, I'm back. Are you back, guys? Can you give me a quick yes, please? Okay, sorry about that, guys. I think for the most part, my things are over for today, so I should not have any more interruptions. But I'll just give 1 minute for the rest of them to join. Say while I'm waiting, just say I'm back. We'll give 1 minute and start. Okay, guys. Okay. In the meantime, let's see. So hopefully, if you're accessing the web shell and if you're typing these commands and things like that, that's what we would need, guys. We need you to access the web shell. Just type in the commands. We'll try to dig deep into the commands and try to understand them. So right now, parent child. Okay, one moment. Let me get rid of these things. And get rid of that. Okay. So now what we did when we said Hadoop FS, back to here. When we give this -p option, what it is doing is it is creating a parent directory. Under the parent directory, if the parent directory room kitchen is not there, it is creating it. Creating the parent directory, under that parent directory, it's creating a child directory. Again, by this time, by the time it reaches here, the parent directory is created. It is now creating the child directory. So what is kitchen? Kitchen is this one. Under kitchen, _1_2 is this one. So if you give -p, it is forcing. If the parent directory is not there, then it's kitchen. Then it's creating it. If you don't give -p, then what it is doing is it's not forcing. Are you understanding, Lokesh? Okay, so let's take a look at a few more commands. Now, take a look at this, guys. Back to Hadoop FSLS. When you say ls, what is happening, guys? Hadoop FSLS, let's say, come back here. Type in this one. You say, okay, Hadoop FS ls. What's happening is it's giving a list of directories in the first flow. That would be the chair, the blue one, the 3 pink ones, and the orange one. Okay, this one, and this one. But it does not give you the inside directories. Are you catching it? Lokesh, are you catching it, bud? It just gives you, it's like, in the apartment, what are all the chairs and the rooms? That's it. Don't go inside the room and tell me what are all there inside that one is what it is. So now, what do we have on room _kitchen h? What did we observe? If we say, oops, come here, bring up this one, room _kitchen h, if you say, we have kitchen 1 and kitchen 2, which is here. Now what we'll do, come here, this room _kitchen, we'll say, we'll copy this one. Instead of ls, we'll say, touch this one, room kitchen, under, we'll create a file. Let us say, we'll call this as chair _kitchen, which is a chair in a kitchen and a h. So now, let's say, we'll run this one. Okay. Now, after we run that, one more time, we'll verify, which is this one. So notice there is room _kitchen h1, and there's a chair under kitchen. There's a chair under kitchen. Chair _kitchen. Is that what we did? Yeah, chair _kitchen. So there is kitchen 1 and kitchen 2 are directories. They are like 2 rooms. In kitchen 1, there are 2 rooms and 1 chair. Everybody catching it, guys? These two are two kitchens. Inside a kitchen, and there is a chair which is a file. Catching it, guys? Quick yes, please. Okay. Now, one more time, I'll repeat the same stuff just so that you understand. One more time, we'll say kitchen underscore h. So chair underscore kitchen underscore 2. One more time, I'm going to touch, which means I'm going to create an empty file in this folder room underscore kitchen, which has a chair 2. Let's say chair 2, chair underscore 2, chair and chair 2. So let's say copy this one. All right. So paste it here, run it. While that is running, one more time, I'll bring this up from here. So now if we verify it, so notice there are two kitchens. These two are kitchen 1 and kitchen 2 are directories, but there are two chairs. Chair and chair 2 are two chairs, which are like files because we did a touch. How about now, guys? Are you catching it? Which is like, if I come back here, what I just did is, this is kitchen 1, this is kitchen 2. And then I individually added two chairs. Let's say we'll choose this one. We'll add, let's say, here's chair is 1, and here's another chair. So inside orange kitchen, orange folder, we have two chairs, which are two files, and two kitchens, kitchen 1, kitchen 2. Are you catching it, guys? Quick yes, please. Gentlemen, ladies, how about others? Are you catching it? Okay, the reason I'm showing you so many times, Lavanya, is so that you will type it by looking at them, which will be helpful for you. At the end of the day, I'll share. I want you to kind of do a little bit of hard work. These things are very, very, things. So I'm going to share them, but put a little bit of hard work there. It will be helpful for you. You can give any names. For the sake of simplicity, I have given these names. Is what is. Now, what is happening is, now notice, totally there are three chairs and a lot of folders, a lot of directories and things like that. But let us say, if we come back here, we'll say ls-r, or more precisely, I think, -lsr. Copy this one. Let's clear this. Let's clear this. LSR. Let's run it. And now notice what we are getting is, it is giving a list of all the directories and all the chairs and all the files wherever they are. These are all the top level directories. Under top level directories, there are two kitchens. Under room underscore kitchen, there is chair 2 and chair h. So what is LSR? LSR means recursive. It will give you a recursive list of all the possible files which are there. In other words, imagine you had two or three more folders, 3 or 4 more folders inside them, a parent child, a grandchild, and a grandchild, and great grandchild, and things like that. All that is given by LSR, LS recursive. Everybody catching it, guys? Quick yes, please. LS means list of files in that directory, list of files and folders, but it will not go deep. LSR means recursive. No matter how many, whether there are 10, 100 or 200, it will give you a list of everything it will give you. Pardon me. Okay. And let's say, come back here. Okay, that is LSR, guys. As simple as that, LSR. Instead of hyphen LS, hyphen R, LSR is a shortcut. Now let's say hyphen LS, hyphen H. Let's say what that does. From here. Hyphen LS, we'll say hyphen H. Okay, so this is human readable format is what it is. So most of them are 0 bytes here. Okay, so let's say if we come back here, Format, file size. File sizes in a human readable format. Generally, a file size will be 671. This is in the form of bytes. That 671 would be here. Well, I'll show it to you in a moment. 671. So that is in bytes. What will that do? That will get converted into 64 megabytes. Is how it will show. That also we'll have a look at it. About that. So that head stands for human readable format, guys. Okay, to understand that, okay, let's now take a look at this. Now, gentlemen, ladies, this is where a little bit of complexity is we're going to increase the complexity. And let's see what that means. Come here, huh? And what we'll do, back to our PWD, let's see, PWD. And let's say here are some files. And let's see here, okay, here is demographic data.csv. So if you say head, demographic data.csv, remember it will give you the top 10 lines. If you say tail, demographic data, it will give you the last 10 lines. Okay, so let's clear it one more time. Here is head, tail, demographic data. Head is top 10. Let's do a clear. And now what we'll do is, now what is happening is, think of it like this. Think of this as our Linux server in our Linux computer, in which, let us say there is a file, which is, let's say this one. Here's a file. This is demographic data.csv. So what is this one? This is a ground floor. There's a file in the ground floor. Now what I want to do is, I want to take this file. I also want to put this here. How do you put? Well, you use put. In other words, take a look at this. Back here, we'll say Hadoop fs -put demographic, demographic, data.csv. Let me make sure that is the name of the file. Demographic, okay, phc data.csv, and we'll say paste it here. Now notice, one more time before this, we'll say Hadoop fs -ls. Okay, we'll start with Hadoop fs -ls. Clear? These are the files we have. Now what we'll do, we'll say put, give it a moment. Now again, bring up ls. Now notice, it shows demographic data.csv. It is in 8,360 bytes is what it is. Okay, so we come here. After this, we're verifying. We'll say -h one more time, just for the sake of understanding. So now if you say -h, notice it says 8.2K. What was earlier coming as in the form of bytes, it's now in a human readable format. So head stands for human readable format, and this is demographic data. So at a slightly conceptual level, visualize what it has done is, for the sake of simplicity, it has copied this file in the ground floor. It has pasted this in the first floor. I repeat, it has copied the demographic data in the ground floor and it has pasted in the first floor. Okay, so what do we have? We have the same file in the Linux machine and also in the HDFS. What is HDFS? Remember, HDFS is our first floor. It's like this is a sofa. Sofa has been copied in the ground floor and it is pasted in the first floor. Okay, for the sake of simplicity, we'll delete this one, delete this one, bring it down, delete this one, and put this here. So we had our sofa here, and the sofa was copied and pasted here. Is what is happening. HDFS is acting like another computer that can be sitting on top of a single computer, that can be sitting on top of 100 or 1,000 or 10,000 computers. it will act like one single computer. Catching it, guys? What we did is we copied and pasted it in the first flow. What is this? This is called loading the data into Hadoop. How do you load the data? You use the put command. Are you catching it, guys? Quick yes, please. Copy single source or multiple files also. You can also put multiple files and things like that. That also we'll see. So what are we doing? We're uploading a file. This is called loading a file or loading the data into HDFS. This is how you load the data. When you load the data, what is happening? That is where the process of this, what we have here is just a few. How many is this? This is 8.2K. It's a very small file. But if this was even a terabyte file or even a 800 megabytes, 800 terabytes file, what will happen? It will look like it is one file, but behind the scenes, the process of splitting, distribution, and replication will be happening. You can also, instead of put local file, so what is the command? We said Hadoop FS put local file. So if we come back here, what we did is we said Hadoop FS hyphen put local file name here, and what you want in the, what you want to call it in that one, that is the destination file. So here, let us say it was local.csv. Let's say in the destination, we want it to be called as destination.csv. You can give any name. 1, 2. And let's say, so put, here is local, and here is destination, is what it is. You can give any name, guys. What is happening is, this local, what we mean by local is, this is there in the local machine. But what is important about put is, but here we can give even a HTTP directory. So I come here, a HTTP file, or we can give an Amazon. If this file is there on an Amazon also, we can give. And we can also give any other location. Okay, so in other words, let's say, come back here. CSV file sample. Let's go here. CSV file examples, CSV file. Download the CSV file with minimum data. So let's say I'm going to copy this one. Copy link address. Come here. Paste it here. That is the link. So now we'll say Hadoop fs -ls. Give the link. And let's say this is users.csv. Okay, now notice, sorry, not ls. We should do a put. So this put is actually loading. It's a simple command, but it's doing some very heavyweight stuff. So now, copy this one. Clear it. Let's run it. Put no such file or directory. /etc. No such file or directory. Okay, how about, let's say, w get. Oh, sorry.
Single quotes.
W get. I'll put a comment of this. Say, come here. Copy this one. We'll say wget. Wget means download. Copy this one. Resolving request sent. Username. So let's say ls. Okay, it's on. So it's right now wget. Hadoop FS is not putting it. So we added a wget. So let me copy this one so that you guys can try this, because it's a long command. Set everyone. Paste it here. I will just share that with you. Put it back here. So wget is actually downloading it from webget. Wget is webget, guys. So you download it here as user name.csv. So notice it downloaded it as username.csv. And say ls one more time. ls-ltr. It didn't get the latest. It got the timestamp at which that was created. It did not put the timestamp. That is why it is appearing there like that. So this is, we are downloading a file. Okay. So let me try another one. Let's say sample. Let's go back here. Sample CSV file on AWS. CSV data file format. Importing sample data from CSV, downloading the cost data. This can be any file. I just want a link of the CSV file. So console, let's say home. Step 1. Export data, Amazon QuickSight. Oops. I just need a S3, AWS, say sample CSV file. It's not Linux command, it's Hadoop command. Importing sample data from CSV file, creating the user import, export the data, create analysis with a single user, exporting tables. Okay, let me try this one. Did this, did this. So they're giving all these things. So I'm just looking for a sample. Yeah, in other words, instead of input, if I give you a location of the AWS thing, it will download it, guys. That's what I'm trying to show to you. Pardon me. The sample AWS CSV file on S3. S3. Supported data formats. Say download sample ASV file. Download the data files. Download a CSV file. Download your monthly report. Oh. Is there any download billing reports? CSV to them. Okay. Query data from S3. No, I don't need that. I just need location. Okay. I guess that will take a little bit of time. So what I'm trying to convey, instead of this put, guys, here, if I give you an S3 location in AWS cloud computing, we can also load the files from the web into your HDFS. In real world, that is what will happen. We have some files available somewhere on AWS bucket or some other cloud. We can give that cloud location here. Even the web, I think I expected it to work, but for some reason, maybe it's not working. What is going on? I need to look into that. Maybe we did a wget. We did put here. It says put. Okay. So I'll look into that, guys. Okay. This is again. So this is again Hadoop FS put is not a Linux command. It is like a Linux command, but it is a Hadoop command is what is. This is a Linux command. So now here, when we do a wget, what we are doing is visualize. Here is internet. Here is internet. And where are we? We are here. This is, let's say, no, this is our laptop or this is the Linux computer. So what was happening was there was a file, say choose this one, users.csv, somewhere on the net, we copied there and wget is pasting it here. Now what can I do? I can copy it from here. I can paste it here. So what is happening is from web, we downloaded it here. From here, we are uploading to HDFS is what it is. How do you do that? Now you say, put this, you say put, I think the name is username.csv/username.csv. Whatever name you want, you can give it. So if you put this, if you put So clear. This one. So you know, let's do a clear. Let's do it. Run it. And if you say Hadoop fs -ls, okay, I'll just do ls. There is username.csv. Everybody with me? Quick yes, please. Are you catching it? So put is copy in the local file system, paste it in the thing. That put is powerful, where it can also actually get from, let me try another location here. Sample. So say GitHub sample CSV. Let's see if this does it. Here's a sample CSV. Let's say address.csv. So let's say copy this one. fs-put, paste it here. We'll say a address.csv in short. Let's see if this works. Let's run it. Oops, run it. No such. Okay, it's not allowing me. Maybe for put, I need to just use another command is what it is, but ideally should be able to take the HTTP, no such file or directory. Okay. Strange. I expected that to work, guys. I'll look into it. I'll get back to it. But everybody catching an idea, guys? Can you give me a quick yes, please? Are you catching what is happening? What is put doing? Okay. Let's come here. This. Let's move to the next one. Okay. Now the reverse is get. Okay. Imagine somehow, let's say, let's take Praharsha. What she did was she downloaded this username.csv into her local file system. From here, she uploaded into HDFS. And at a later point of time, let us say she deleted this one in her local file system. It is there in HDFS somehow. It ended up at a later point, she deleted, which means, let's say, come here. We'll now say rm user name.csv. Okay. So first say ls username.csv. Verify the file is there. It is there. Now we'll say rm user name.csv. It is deleted. If you say ls username, you will get no such file or directory. So we removed it. But what is there? We are observing the file is there Hadoop fs ls user name.csv. We'll just say like that. We'll be more specific. So the file is there where in the Hadoop, but it is not there here. So now what I want to do is I want to copy this one here and bring it back and put it into the local file system, which means earlier we got it from here to here. Now what I want to do is I want to get it from here to here into the local file system. What do you do? The reverse of that is instead of put, you say get, which is Hadoop fs -get username.csv. Say username.csv. Paste it here. So now notice, if I do this, put is opposite, get is opposite of put. I should see ls username.csv. And if you say ls-ltr, notice it will be the last one because it has taken a new timestamp, the latest timestamp. So what is put? Put is copying in the ground floor, pasting in the first floor. Whereas get is copying in the first floor and pasting it in the ground floor is what is happening. Put, get is opposite of put. Everybody with me, guys. Quick yes, please. Okay. So next, let's say, come back here. That is get, as simple as that, guys. Okay. So back to, again, a quick look at Hadoop. say, okay. Okay, Hadoop is a software framework. It does complex things. It is doing many of the complex things internally. It is hiding the complexities so that we don't have to worry about them. It supports data intensive. These are big data. These are related to big data, and a lot of data is involved. That is what is data intensive. It is a distributed file system. It's a distributed application. A distributed application means it is distributed. Hadoop is generally on tens and hundreds and thousands of servers together form one Hadoop server, one Hadoop application, or one Hadoop framework. You don't use when you just need one or two. To start with, we'll start with one or two, but in real world, they become tens and hundreds and thousands of computers or servers that act like one is what really happens, guys, okay? It is free. It enables applications to work with thousands of nodes and petabytes of data. When we work with Hadoop, whether you have 1, 10, 100, or 1,000, it will work with everything. The size of the data is independent. It will work. It was inspired by Google's MapReduce and the Google file system. Means originally it came from Google. Google is the godfather of this one. It was based on these papers which were published, a little bit of academic literature. Again, when they say Hadoop, it is a group of tools. What is Hadoop? It is running applications on big data. In other words, it is an application which is used for big data. It is free. Open source means it is free. And not only can we work with structured data, but we can also work with unstructured data. In the world, 90% of the data is unstructured data. That is the seas and oceans. And what is a tool which can work with unstructured data? That is Hadoop. Why? If you can find fish in rivers, you can find, with the help of Hadoop, it will help you find big fish. Okay? Before Hadoop, what was happening was when there was big data, the big data would not fit on a single computer. And if they use multiple computers, they did not have frameworks to work in an easy way. So what happened was it was a big problem. Okay, that's where Hadoop came in. It takes the big data, splits them into small pieces. It uses cheap servers. It splits them into small splits or pieces called blocks. It calls them as blocks. Each block is by default 64 megabytes or 128 megabytes. That depends on the administrator. And then it replicates. It is distributing and replicating, SDR. Then what does it do? Again, if one of the server fails, we have a backup. That is how it is protecting the data. Okay, so let's say, let me come here. Let me get rid of this one. Save these things here. Put them here. Get rid of this one. This one cluster. This here. From here. Bunch of them seem to be. Put this here. Oops. Okay. Bring this up. Okay, resume it. Okay, look at the comments in a bit. So now let's get a little bit deep into understanding Hadoop. Back here, what is a cluster? A cluster is nothing but a group of computers. In other words, notice this is rack 1, rack 2. A rack is a group of servers or nodes. And a group of racks together is referred as a cluster. So cluster is called a group of racks. A group of racks is called a rack is a group of servers. Okay, what is this together? This is called Hadoop cluster. In a real world, this is what will happen. Here is a data center. In a data center, let us say, this is one Hadoop cluster. They may maintain another Hadoop cluster here. Just visualize that's a big one, big square or rectangle for sake of simplicity. There's another Hadoop cluster here. What is this one? Each box here, the blue, the green, and the yellow, they're different clusters. They may have hundreds and thousands of servers inside them. So what is this? That is a data center. The pink box is your data center. A data center is a group of clusters. A cluster is a group of racks. A rack is a group of servers. Everybody with me, guys. Quick yes, please. Say get rid of this. Say get rid of this. Get rid of this. Get rid of this. Okay. So now, gentlemen, ladies, are you with me? Simple thing I want you to keep in mind. A rack is a group of servers and a cluster is a group of racks, is what it is. Now, in the world of Hadoop, a few terms to remember from a slightly networking standpoint is switch. What is switch? Switch is something which is connecting all the servers within this rack. This is called TOR switch, top of the rack switch. This is called central switch. Central switch is connecting one rack to another rack. So these switches are used. Using these switches, the data is flowing from one server to another server, to from one rack to another rack, and things like that. So this is called TOR switch. This is called central switch. That's all, as simple as that. That's what you need to keep in mind, guys. Okay. But notice the blue and the pink colors here. The blue colors are all the cheap servers. The pink colors, there are only 2 or maybe 3 of them here. These are the expensive servers. These are master servers, master nodes. The blue colors are all the worker nodes, master slave. The architecture of Hadoop is master slave or master worker. In traditional world, almost every server was enterprise class server. They were expensive servers. Expensive servers are called enterprise class servers. But in the world of Hadoop, you minimize it. You limit it only to 1, 2, and 3. And you can maintain these hundreds and thousands of the commodity servers. They're all cheap servers. They're not so expensive. Everybody catching it, guys? Quick yes, please. The architecture of Hadoop is master server or master slave, is what it is. The pink servers are called as the masters. Only the masters are expensive. And they're just 1, 2, or 3 in a real world. All the remaining are workers, is what it is. And then we'll talk about the client in a bit here. So let's move a little ahead. So here is an example of how these servers look. So take a look at this. Here is the name node. This is a master server. Sorry, come here. This is a master server. Notice 64 GB RAM. Actually, they are much higher. They'll be anywhere from 200 to 300 to 400 GB RAMs and things like that. They'll be much more higher. Hard disk is 1 terabyte. This is Xenon with 8 and 3 times 3 network wires going into it. That is CentOS, Red Hat, and things like that. Different kinds of operating systems. This is how the master server's configuration will look like. This is just for your, you don't need to buy hard this or anything, just so you have an idea. Generally, the RAM is very, very high. The processors are generally very, very powerful processors they use there. That's why they're expensive. And now you take a look at data node. These are just like our laptop configurations, 8 GB, 16 GB, 4 GB in some cases. And they have many small drives, much less cores, less support and things like that, because these are servers. They are anyhow slightly more faster and powerful than our laptops, even though they are inexpensive. It is what it is. So master servers are generally very, very highly high spec, and they're very powerful. Everybody catching that, guys? Quick yes, please. Okay. So again, just another look, 64 GB RAM, 1 terabyte, and so on. Here is RAM, and these are the worker nodes. So here is the Hadoop architecture, the master slave or the master worker architecture. The way Hadoop works is only 1, 2, or maybe 3 servers are masters. These are expensive. They can be anywhere from $100,000 to $1 million. These are somewhere around $5,000. The slaves and things like that is what it is, guys. Okay. Now what happens is, in these master servers, there are a few processes running. Their names are name node and job tracker. Back to, let's say, go to task manager. Notice these are the processes which are running. Okay. And scroll down, there are other processes and so on. What are they? They are like the process in Linux. Say close this one. So what do these processes do? These processes manage the other worker nodes. What do worker nodes do? Worker nodes keep updating. What do they update? Every few seconds they send a message to this master and says, I'm running, I'm alive, I'm not down. If any of the message, worker or slave, does not send a message in a few seconds that is configurable, then the master will make a list of them. Master is maintaining a list of all the nodes which are sending. What is this? This is called metadata. Master maintains this metadata. Which one is up? So slave 5 is continuously sending and keeps sending, so this is good. But let's say slave 1 did not send a message, it will immediately make a note of it. This is called metadata. This is maintained by this master called name node. Master maintains a list of all the servers, workers which are up and running. And what happens? What is it which is sending a message? It is actually two processes called data node and task track. These are the two processes which are sending the messages to the master. What is data node? As the name suggests, data node is a process which is running, which will send a message to the name node saying that it is up and running. It will also send information. How much is the free space? How much is occupied? So what will the name node do? Name node will also maintain how much free space is there versus how much is taken and things like that. What is that? That is called metadata. Name node maintains the metadata. Data node is sending the information about the storage. How much is free versus how much is not free. Coming to task tracker is also sending some information. What is information task tracker? Task tracker send its information to something called job track. They will send it saying that if a processing is happening, or if a processing is happening, it will say, I'm busy. Please don't give me any work. If the processing is not happening, then it will say, I'm available. Please give me some work. What is it? That is the kind of information that the job tracker maintains in its metadata. What is it? These are all the workers. These are all like the employees. These are all like the project managers. Just like in an IT company, all the developers are sending their status reports to their managers. The masters and the workers and the masters and the slaves are working here. That is what is called, that is what is the architecture of Hadoop, which is referred as a master worker or a master slave architecture. Everybody with me, guys. Quick yes, please. Okay, so if you come to the name node is the master of the system, the most important component of the Hadoop. Hadoop at a high level, a Hadoop we are coming down at a few more levels deep. What is it? It is a group of computers. In that group of computers, there is one very, very important computer or server. What is it doing? It maintains and manages the blocks which are present on the data nodes. In other words, data nodes are like the cheap servers. They're like the taxis. This is like a Ferrari car. You maintain one Ferrari. Okay. And what is happening is the name node is maintaining which are the servers which are up, how much free space is there, how much is taken, and internally at the time of splitting the blocks, distributing and replicating, what is it doing? It is maintaining. Each of the block is getting saved into one data node. Okay. And what do these data nodes do? The data nodes are sending that. Okay. In other words, let's say here is the, let's say the master server. Here is, let's say, the metadata. We put it here. And here is, let's say, let's call this as, oops, choose this one. Let's call this as data node 1. We call this as, let's say, data node 2, the second card. And we'll say this is the third card, data node 3. Now let's say we have two files. Here's file 1 And let's say here's file 2. And let's say come to file 1. File 1, let's say we'll call this is 100 megabytes. Then come to file 2. Let's say this is 200 megabytes. Okay, so now imagine we give it to Hadoop. What is happening internally in Hadoop is it is going to take this file. It is going to split into 3 parts. So 100 MB is 64. It will split it into 2 parts. Here is 64 MB. So I give this 64 MB. And here is 36 MB. Small one. Now what does it do? It will put 64 MB here. Let's say, for sake of simplicity, this is data node 1, data node 2, data node 3. So it will put 64 MB here and 36 MB here. Okay, then what is Hadoop doing? Hadoop is replicating, which is it is making a backup of the blue one here. It will also make a backup of the blue one, save the third additional copy. Similarly, the pink one, also the backup is made. Oops. Backup is made here. The backup is also made here. Okay, now what is happening is the data nodes, what do? The data nodes are going to update the master saying that, hey, I have one pink block and I have one blue block. This will also update it. I have one blue and one pink, one blue and pink. What is that? That is the metadata. Cool. So in other words, let's say, so it is, let's say this is data node 1. It says I have one pink block and one blue block. Then here is data node 2. This is the metadata they are sending. This is also saying I have one blue block and one pink block. These are nothing but the splits of data that Hadoop created. Everybody catching it, guys? Quick yes, please. Okay, now another way to visualize this is, let's say I put this data node 1 here. I put this data node 2 here. What are these data nodes? These are individual computers. And what is happening is the blocks are in the individual computers. These blocks are in the individual computers. So let's say I put this here, put it here like this. Say put this here, this also here. These blocks are nothing but the splits which Hadoop created. Now what is Hadoop behind the scenes? Let's say choose this. We're saying choose this. Yes. So in Hadoop, okay, what is the green one? Green one is, this is the green one. The green one will be here. And the red one, we have not yet split and distributed it, but the red one will be here. Let's say the red one is 200 megabytes. So that will be 64, 64, 128, and another 64 is 198. That will be 4 blocks. We need to visualize 4 blocks are split into different computers. At a Hadoop level, it will look like it is each of them are one file. But behind the scenes, they are split and distributed into different computers and different blocks is what is happening. Everybody catching that, guys? Quick yes, please. So ideally, this is just to explain. For you guys, we will never really go at this level and look at the blocks here. We will most of the time, we'll be here. We are just reading the files here. We're saying, hey, I have one file here, I have 2 files here, or I have another file here. This is 10 terabytes, this is 20 terabytes. That can be any number of terabytes, is what we generally look at, guys. So what is that? That is the kind of metadata. This is the data. These data nodes will send to their master saying that, hey, I have this much free space. This is the list of blocks and things. This is called metadata. This is very, very important. With this metadata, without this metadata, Hadoop cannot run. And how is this metadata getting updated? The data nodes keep sending every 3 seconds. They keep sending 3 to 20 seconds. They keep sending. That is called heartbeat signals. Okay, slaves are deployed on each machine. So when we say master and slave, these are processes. Name node is a process. Data node is another process. Data nodes are constantly, they look around. They have configuration files where they look, they know how to look, where the IP address of this one is. And they try to update or they try to send the metadata. Everybody okay with this slide, guys? Quick yes, please. Okay. So one more time, master, slave or master worker architecture. We have here this whole thing. These are all the masters. This is about the data. This part is about the data. And the data storage. One is about the storage, another one is about the processing. Here comes the processing. The processing is a job MapReduce part of it, which we are here to talk about. So what do the data node process do? They send and say how much free space is available, what is the list of blocks. The task tracker sends a message to its master called job tracker. It tells if it is busy running some processes. Does it have is it ready to take another task or not? It is computing the task. This is about the computation. This is the heart. I'm sorry. This is the head of the brain. This is the HDFS. This is the heart of the Hadoop, which is the MapReduce. MapReduce is used for processing and analysis, whereas HDFS is used for storing the data. Everybody with me, guys. This is called master worker architecture. In Hadoop 2.0, I think in 3.0 also, they have renamed, they made a small change. Instead of job tracker and task tracker, they call this as resource manager and node manager. In 1.0, this was called as task tracker. This was called as job tracker. Now they changed it as node manager and resource manager. And let's see. I'll show you those list of processes also, guys. So that's a master worker architecture again with new names. And looks like I'm already in the cat. Okay. Pardon me, sorry about that. Let's take a look at a few more commands here. Say Hadoop, FS.
Sir, 5 minutes break, sir.
So before that, you say cat and back to Linux. Let's see what are the, let's say clear, say cat user names.csv. These are the username. Small file. What can we do? We can say Hadoop fs type in cat usernames.csv. Okay, one more. CSV. This will cat. This is showing the file in the Linux file, whereas Hadoop fs cat is showing the file in the Hadoop. As simple as that. It is going to the first floor and getting it here. That's what it is. Okay, guys, let's take a few minutes break here. 4:19. Let's take a short 5-minute break. 4:25. Let's meet and continue from here, guys. Okay. Everybody okay with that? Okay, guys, are you back? Can you give me a quick yes, please? Okay. So Hadoop FSCAT, it is nothing but it is reading the file. So let me come back here, back to our example. Say, okay, so I guess I'll take this one, blank. So imagine this is our Linux, this is our computer. And let's say we'll say here is the Hadoop layer. When you say cat, we have a file here. Okay, whatever is the content of that file. Let's say the content of that file is this one. When you say cat, whatever is the content in that file is displayed to us. Change that to that. Change that to that. But when you say Hadoop FSCAT, okay, what do we have? We'll say there is some file here. And what is it? Well, it has some content inside it. Okay, so what is happening is what we are seeing. What we are seeing is this. Say, we'll put it here. Hadoop FSCAT is displaying the content of the file is in the Hadoop, whereas cat is displaying the content which is not in Hadoop, but which is in the Linux file system. So this is the content in your ground floor, that is the content in your first floor. What is first floor? First floor is like the first floor apartment. It's like a virtual apartment. It looks like there is an apartment, but there is no apartment actually. It's a virtual layer. What is special about that virtual layer? That can sit on 10, 100 and thousands of computers. That is what is Hadoop. Are you catching the point, guys? Quick yes, please. Okay, that is cat. Then we have CP. Okay, so now back here, let us say, when we say put, what happens, guys? Here is what is happening. When you say put, it's copying it from the ground floor, pasting it in the first floor. When you say get, it is copying it from the first floor and pasting it in the ground floor. Okay, but when you say copy, okay, let's say, come here, is copy. When you say Hadoop FS copy, there is a file, let's say visualize, there is already a file here. It is going to copy. So in other words, put is copying it in the ground floor and pasting it in the first floor. Get is, choose this one, copying it in the first floor and pasting it in the ground floor. When you say Hadoop FS copy, which we are about to do, it is going to copy in the first floor and paste in the first floor as another file. So let's say I choose this one. Let's say I choose this one. It's going to have a different name. So let's say Hadoop FS CP. Come here. So start with, let's say, back to Linux terminal, clear. So if you say ls-ltr, username. So we'll first do cp username.csv as users.csv. So this is in the ground floor. Okay, so let's say back here, cp username.csv, so users.csv. Next, what we'll do, we'll copy this one, just add a Hadoop fs -cp. So if we have a file called users, username.csv, it is going to rename that to users.csv. So if you run this, give it a moment, then say Hadoop fs -ls. So there is users.csv. What did you do? copy is copying from the first floor and pasting in the first floor. Okay, so whereas the put is going from ground floor to first floor. This is put. Okay, put is going from here to here. Get is coming from top to bottom, whereas copy is going from first to first, as just as another file. Catching that, guys? Suresh, are you catching that? Okay, so let's see what else we have. That is copy. Next, let's say copy multiple files. You can also, let's say, back to here. Now take a look at this. Back here, we'll say Hadoop fs-cp. We have demographic. We have demographic data.csv and username.csv. Let's see. test2.txt, test3.txt. Okay. Demographic data.csv and username.csv. And let's say we'll put it into a directory. Let's say we'll call that as let's say test dir slash. Let's see what happens. So first we'll say clear, paste this, run it, give it a moment. Test dir is not there. Okay, let's say Hadoop fs-ls r recursive. We put that into kitchen_1 or room_kitchen. Instead of test dir, we'll say room_kitchen. room_kitchen_h_h. Okay. That's 1 month. Okay, sorry about that. So let's try this one, guys. Copy this one. Oh, I already did that. So now we'll verify again. Hadoop fs-lsr. So let's see, room_kitchen_h now has demographic data and usernames data is also copied. Everybody catching it, guys? Quick yes, please. Okay, so next, that is copy. Copy from local. Now, it is similar to the put command. It is just another one here and there. So you can say, so let's say, clear this, ls-ltr. And what do we have? We have demographic data. Let's see, chair1.txt. Do we have a data? Didn't we create a data? Chair1. I didn't create data. I think it was created by somebody else probably. How about this, guys? Let's say we'll copy users.csv as, let's say, what is the file we have given here? Okay, let's say data.csv. Okay, ls-ltr, verify there is data. That's the file we created. Let's do a clear. ls-ltr. Okay, so now what we'll do, we can do a put. If now this is there in the Linux file system, which is the ground floor. Ideally, we'll do a put, but here we have similar command copy from local. So Hadoop fs back here, and say Hadoop fs hyphen copy from local, and we'll say data.csv, data.csv. This is same as put. Say clear, say Hadoop fs hyphen ls. This we should see data.csv is copied, pasted. So after this, I'm just verifying Hadoop fs hyphen ls. Catching it, guys? Quick yes, please. Okay. Next one is copy from local again. The same thing you can also copy from other. If there are sometimes we have more than 2 Hadoop frameworks. So from one Hadoop framework to another Hadoop framework also you can copy it like that. You can use a put also there. You just give the different location, the same thing. Copy local to URI. I see. Except the destination is restricted to local files. Okay. Local file reference. Copy to local is get. I'll not execute this. It is same as get, guys. As simple as that. And copy HDFS TR. Okay, this is a big one. Copy to local. So what happens is copy HDFS folder to local directory. Generally, HDFS folder or directories are very big and huge. We should be very careful. You should not copy them from HDFS to local unless it is required, unless you're very sure. Generally, it is used by the administrators and things like that. Multiple files are copied, as simple as that. Okay, now, next one's another simple one. Here is move. Now, what is move? If you come back here, we have seen we copied this file here, we pasted it here. Let's say this is from here. It was originally, let's say we'll call this as F1. Then we pasted it. So here, this was pasted as, say, come here, F2. Was copied and pasted as F1 and F2. Now, let's say what we want to do is we want to move this file F2 and paste it as F3, or in other words, for the sake of simplicity, let's say I want to change this one from F2 to, let's say, F3. What is that? That is what move is. Hadoop FS move. Move is nothing but cut paste. Okay, so let's say it is data.csv. Back here, say Hadoop FS hyphen move data.csv as, we'll say, new underscore data.csv. Let's run it. So now notice data.csv has been renamed as new data.csv. Okay, we can also copy this one, paste it here. You are verifying Hadoop FS hyphen ls. Now we'll take new underscore data.csv. We'll move it from here to, let's say, give any folder name, room underscore kitchen underscore h. Room underscore kitchen underscore h slash. Okay, so before that, say lsr. Put this here. So if you notice, here is new underscore data. Under room underscore kitchen h, we have demographic data chair 2, chair 1. We also have kitchen 1, kitchen 2. We also have username, but the new underscore data is not there. So let's clear this one. Back here, we will move this one. Move it. LSR. So notice now, new underscore data is here. So what is happening is when you move, you're doing a cut and a paste from where? From first floor to first floor. In other words, you're cutting this one here and pasting it inside another room or anywhere within the first floor to first floor. Everybody catching that, guys? Quick yes, please. So move is cut paste, copy is copy paste. Put is also copy paste, but it is coming from ground floor to first floor. Okay. How about others, guys? Is everybody doing okay? Compared to Python, how are you feeling this Hadoop and big data, guys, compared to Python? Can you give me a quick yes? Niharika, Suresh, come online. Just give me a friendly opinions, please. How are you finding it? You're finding it easy, tough, or interesting? What do you think? Is it boring?
Little bit
Come
of
online.
need to
Just
practice.
let me hear your thing. It's interesting. Okay, interesting is good. How about others?
Naveen, it is
Don't be silent.
interesting.
Remember, your participation will be very, very important in your future meetings and things like that. This is a good place to practice. Even if it is not so good, we can say it. Tough also is okay. But you have to open up yourselves, guys. You have to open up yourself to your team. That's teamwork. And you need to practice it. Nobody will give you a chance. They will just directly judge you. Nobody will give you advice or suggestions in real world. Be aware of that, guys. They'll directly judge you and give you ratings and things like that. So just be aware of that. Okay. I'm not trying to scare you, but that's what it is. So again, move. Okay. The same things. We're moving into full path and things like that. Next one is RM. Yes, practice is very, very important, guys. So as the name suggests, RM is removed. So let's say now come here. We'll copy this one, paste it here. We'll say instead of just say RM, that is removing, deleting it from the first floor. Let's run it. So there it is, trash. Okay, so now if you come back here, try to verify it. Room underscore kitchen has everything except the data.csv, new data.csv. Everybody with me, guys, quick yes, please. So what is happening is almost everything is a Linux command that we have seen. Instead of just saying RM, we are saying Hadoop FS hyphen. Hadoop FS means that is the Hadoop layer, Hadoop framework. It is a virtual layer. But for you, it is like the ground, first floor apartment. First floor is what it is. Delete multiple files. Okay. Again, if you give -r, you can delete multiple files, but I will not delete anything here. Another one is skip trash. Delete file with skip trash. I think -skip trash, delete the file permanently, bypass the trash. So generally what will happen is just like we have a trash or a recycle bin in Windows, in Hadoop also, the administrators maintain a trash just in case somebody, because these are big data files, what happens in real world is they will take hours and days to load the data. If somebody accidentally deleted it, then they will first put them in the trash. If you give the skip trash, then you're permanently deleting it. Generally, you leave this command to the admins. You don't do skip trash. You just leave it. Admins will later look into that and they will do complete removal and things like that is what it is, guys. Okay. Everybody with me? Quick yes, please. Okay. Next one is RMDR, as the name suggests. So let's say, start with -LSR. Yeah, let's say clear. Run it. And now notice room_kitchen h as a bunch of files. We have demographic data. We have 2 directories. We have 2 files, which are 2 chairs and kitchen. But what we'll do is, let's try deleting room_kitchen h. Copy this one. And instead of RM, I think it is RMR, room_kitchen h is what we'll do. So it says RMDIR. Let's try RMR. We've already done that. Let's reduce. So now notice it moved trash policy default. It moved this one, which means let's do a clear. So here is room_kitchen, which all with all these things. Now let's say clear. LSR. Notice it is there in the trash. It is indicating in .trash for every folder. It creates a .trash, and it is there in the trash means these have been deleted. Room_kitchen, and here are the actual files. Are you catching it, guys? Quick yes, please. Okay, that is here it says RMDIR. You can say RMR. Okay, next again, tail. Okay, let's say now come back here. Let us see. We have demographic data.csv. So clear it. Say Hadoop fs -tail demographic data.csv. There it is. The last 10 lines ideally is what it should give. It's giving a few more lines here. It is same as tail. I don't think we have anything like a head here for in Hadoop. So let's say clear. So here is tail. I don't think it gives us a head, but it gives us a tail. It is probably unknown command. It says unknown command. Okay, so we don't have head, we just have a tail. Tail is nothing but we are tailing the file on the first floor. Okay, next disk usage, DU. So let's say clear. LSR, let's bring up LSR. These are the different files and directories. Now let's say this is about 8.2K. These two are very, very less. So if we say Hadoop fs -du, just press enter. Demographic data. So trash has that much data. So disk usage, DU is for disk usage. So let's say you say DU here also in Linux. You just say DU. It will give you how many bytes each. These are all the hidden folders. The dots are all the hidden folders. Disk usage. And let's say, if you say DF, this is disk free space. Okay. We can also say Hadoop fs -df. Looks like we have 47. We used up 47%, or in other words, this used up. Hadoop used up 47. It still has 53%. That is the entire Hadoop, I think, not just our service. In other words, it is the disk usage and disk free size, guys. As simple as that. You can also say Hadoop FS. Let's do clear. Say Hadoop FS. Oops. Hyphen du hyphen h gives you a human readable format. So it's saying it's taking 8.5K kilobytes, 8.2 kilobytes. This is 176 bytes, 176 bytes. They're two small files. So let's say this works. So it looks like we use 664 gig is used on this Hadoop. Its total size is 1.4 terabytes, somewhere behind the scenes when these guys configured it. Still, we still have 672 gigs available. 47% is used up. That means roughly 53% is still there. Available is what it means. Okay. So that's another Hadoop FS hyphen du hyphen h is another one. Free space. Du, as the name suggests, disk usage of the disk free space. You can say Hadoop. You just type in here. And we are looking at under Hadoop, these are all the possible things. We don't need to know all these things. Most of the time, we'll be working with FS from a developer standpoint. The remaining things are the things which most of the times admins use it. But under, if you say Hadoop, FS, enter, notice it gives you different things here. What we are doing, we looked at cat, again, change mod, change group, change owner. Here is copy. These are some of the Linux commands we looked at. Here is get. And here is move, here is put, remove directory. Again, so some of these things we don't really use, but the admins use them. But these are the most commonly used commands, guys. So next disk usage, same. FS expunge to empty the trash. Again, generally you don't do it. You leave it to the admin, because if somebody accidentally deleted, and that's a big file which is sitting there in the trash and you expunge it, you may not even have rights to expunge it. That means you're emptying the recycle bin. Will not run it because here it's not our Hadoop, and we may put others. touchz create an empty file. Hadoop FS touch or touchz, it creates an empty file with zero length. We have already done that. Validate or perform various tests on file and directory in HDFS. I see. So let's see. Okay. So again, if there is a file, and I think -d gives you if the path is a directory or not. fs-test. You are right. Say fs-test -d. And if you come back here, clear. So LSR is a list of files, and let's say we're looking for demographic data, or let's say users.csv. Let's see what that gives us. Clear? Paste it. Enter it. -test -d users. Okay, it doesn't give you anything. Valid perform various tests on file and directory. Check if the path is a directory. Okay, we do have users.csv. Let's say we'll give something which is not there. Not much. -e. It's been a while I use this command. So, okay, I'll leave this, guys. We'll later come back and check that. Let's check -z. Should be a simple one, shouldn't really. Oh, sorry. So test, and here is test and DEFZ. These are the options here. -test, DEFZ. I'm giving the path for some reason. Doesn't really seem to be giving me these things, and that will come back. It's not a very say Control Z, Control C. Still clear. One moment. See JPS works. It's only giving, okay. Doesn't log me. Okay, so I think I don't have the root privileges here. Okay, so now we still have a few minutes. Today I lost a little bit of time, so I'll take a few additional minutes and try to cover a few more things here, guys. As I said, a little bit of academic explanation is there. So let's see. What we have done is, when we do a put, copy, all these things, what we are doing is we are loading the data into Hadoop. Choose this, put this here. And the first step is we load the data. After we load the data, that's where we use tools like Hive, Pig, MapReduce, Python programs, and we analyze the data. That's where we may use machine learning and other kinds of things also come into the picture. Then whatever the results we come from that, we will store them back into the HDFS. In other words, imagine a very big data. Let's say this is 10 terabytes. So this is 10 or maybe 100 terabytes unstructured data for the sake of simplicity. Then what we'll do, we will go ahead and write some programs. The programs will run on the 100 terabytes of data and they will generate the result. The result is again, let's come here. The result is again stored somewhere. Where is it? Let's say come here. It is stored, let's say, put it here. So the result may be much smaller. Choose this one. Oops. Maybe 1 terabytes. You process 100 terabytes of data. Your result may be generally only 1 terabytes. This is the data which is generally used for visualization, used for machine learning and things like that, because there's a lot of data cleaning, data filtering, which is happening. Okay, 100 terabytes, you process that. But what happens is the processing of this 100 terabytes of data will really take a long time. That is where the Hadoop comes to your rescue. How many times did our customers type the word refund into emails, into the customer service? What does that mean? Imagine one of the universities in USA, what they did was they took their 20 years of emails and they put them into a Hadoop in a big file. Then what they did was they ran a program which is like a word count. And what they understood was, this is the word which was appearing most number of times from the international students or from the students who were getting admitted. They took all the emails of the students who were getting admitted for the first time into their university. And what they were surprised to find was, when they processed or analyzed it, this was the word. What does that mean? It looks like a lot of people who are getting admitted have been started asking refunds. You may think that's a small thing, but what is happening? That means there is some problem in the university. A lot of people, a lot of students who are trying to get into this university are having some problems getting into getting admission. That is why after they send some money and things like that, they started asking for refund. Now, what is that? That is just a simple example, but it's a very useful insight for the university. Now you can imagine if on one word, they're able to analyze 15 to 20 years of data. Okay, there are infinite number of such scenarios that they can analyze on that data set. And that is where the businesses are going mad. They're coming back and saying, hey, I can help you, I can help you, I can help you, and things like that. What is that? So the processes you load, then you analyze, then you store. All those data is then further analyzed and things like that. That is called the workflow. Workflow is nothing but the group of steps which are happening. Okay, so again, back to a little bit of theory here. Snap it. So name node is the master. Name node is the master, the big guy. This is the most important, expensive server. And it manages the namespace. The namespace is the metadata. if you know of a project manager has, let's say, a group of developers. Each developer is working on one task. What they're working, how much they're completed, all this thing. What is this? This is what is the project plan. The namespace is the metadata. Metadata is the project plan of the master. So the master is constantly listening to the data nodes. Data nodes all report to the master. Okay, what is this? This is the storage part of it. Then you have resource manager, who is another project manager. This guy is purely maintaining. This guy is maintaining the storage information. How much free space is there in each data node? This guy is maintaining which node is busy performing some task versus which node is free performing some tasks. Is what it is, guys. So he's another manager. He's just mainly seeing who's free versus who's not free. And name node is another one who's just tracking who has free space versus who does not have free space. Okay, that is what is called master worker. HBase we'll talk later. And this is a slightly more detailed overview of whatever we discussed so far. I'll quickly discuss this. The most important thing is name node has namespace. They call that as namespace. That is nothing but the metadata. All the nodes, which are all the data nodes, what permissions they have. These are all the other file related information. And it maintains the storage information. Okay, what are all the data nodes, what are all their blocks and things like that. There are other tools. Admins use some tools to tackle some problems. Generally, metadata names, they don't give any problems because they are very expensive servers. They are very reliable. So again, one more time revisiting. You can read these things in detail at a later time. Name node is the master. Data node is the worker or the slave. They constantly report. Just like a developer is reporting to the project manager. They're constantly reporting to the name node about how much chunks of data is there. Do they have any replicas? And what is the state of the replicas and things like that? They keep updating their master, as simple as that. I want you guys to later dig into it. In various ways, I've been explaining the same thing to you guys. Okay, guys, everybody with me? Quick yes, please. The same thing again. So academically, I have given a bit more theory. Only one name node is used in a cluster. That's enough because they're expensive. Data never resides or passes through the name node. In other words, the master is never performing the actual work. He's only delegating. He's saying, hey, developer one, you do this task, you do this task. And then as you do it, you keep updating it. But he's never doing the task. It keeps track. He's the project manager, so he's maintaining the project plan. So the default chunk size can be 128 MB, 64 MB, 256 MB. It is generally in the orders of 64 MB. That depends on the admin who is working on the day. The default replication factor is 3. By default, Hadoop replicates into 3. Data nodes communicate with other data nodes. Touch you. Okay, so internally data nodes can also communicate with other data nodes. Is what it is, guys. Okay, so let me go a little bit deep here. So here is the right. So what happens is this is our laptop. Imagine here's our laptop and we have a file. The file is split into 3 blocks. Let's say this is 150 MB, 64, 64, 128, and 22. Okay, so here is 64. Here is another 64 MB, and the remaining is 22 MB. Say give this one, this is a small file. So now this is our laptop. When you say Hadoop FS put, what is happening is these are the 3 things which are happening first. It is splitting into blocks. Now what it does is, it is internally, the laptop is communicating. The name node can be on the other server. In our server, everything is there in our server only, but ideally in a real world, the Hadoop in your laptop will communicate to the name node and say, he'll ask the project manager, hey buddy, give me 3 developers. And he will come back and say, okay, developers 1, 5, and 6 are available. Okay, now what will Hadoop do is, from your computer, Hadoop will stream the data. Will send block 1 to this one, will send block 2 to this one, block 3 to this one. What is important is it is not sending to the name node and sending it here. It is directly coming from your laptop into the data nodes. The data is flowing from client to the data node. Again, all these things we were writing code. Now we don't have to write code. There's a lot of performance optimization in this one. That is why what is going on. That's why we are understanding. Client writes block directly and data nodes replicate. So what does this do? This will go ahead and after you write it to data 6, data set, this one, the replication will begin. Internally, data node 6 will say, hey, buddy, here I'm sending you a copy. I'm sending you a copy. Make a note. The same will repeat in other data nodes and it will keep going. That is what is called writing, preparing for HDFS writes. So if you go a little bit deep, what's happening is there's a file. So let's say one block is coming from client to here. This is 64 MB. What happens is the 64 MB will not come in one shot. It will be streams of data. A little bit of data will come here. As the data node, as this data comes here, what it will do is it will send a message to your laptop and say, hey, buddy, yes, I received a little bit of data. Send me more. During that time, what will happen is the data node, as it is waiting for more data, it will send this one from here. Oops. Choose this one. It will create a copy. It will keep sending this stream of data, whatever it received to here, and it will again follow the same process. It will send it here. This is called pipeline writing. So in other words, like water, like a tap of water is flowing into this bucket. From this bucket, it is going into this bucket and this bucket. So imagine bucket 1, bucket 2, bucket 3. And there's a tap here. So there's a tap here. So imagine as water is pouring here, and imagine they're all connected here. What will happen? The way water flows is you don't have to fill it up. And then you don't go from here to here. What happens is, as little bit of water gets filled up here, okay, the water keeps flowing from here. So what is happening? This is called pipeline rate. As it reaches this level, you will also notice these two will reach this level. That is how the data is flowing in. This one, this is called pipeline rate. Everybody with me, guys? Quick yes, please. These are the internal engineering aspects of the HDFS, that is pipeline rate. Once all the data nodes receive the complete thing, they will send a message to the name node saying that, hey, my bucket is full, my bucket is full. That's when name node updates its metadata. It's like saying all the developers are saying, hey, buddy, task 1 is done, task 2 is done, task 3 is done, and the project manager is making note. Okay, so developer 1, task 1 is done, developer 2, task 2 is done. He's updating his metadata. What is that? That is what is happening. Okay, similarly, when we have, just like we have a single block replication, a single pipeline, right? For multiple blocks, what is happening is the same process is happening. Block A is being sent here. Block B from here is being sent to here. Block C is being sent from here to here. So now let's say this is block C. Let's say this is block B. So what is happening? So block B from here immediately is filling up another bucket. And this is filling another bucket. Similarly, say the same process continues. From here, it is block A. It's going from here to here, and block C is coming from here to here to here. This is called multi-block line replication. Or in other words, if you store 1 terabyte of file, it will end up being 3 terabytes. So it's a lot of network traffic. But these things are done only once. Later, the code moves, the data does not move. At the time of loading the data, a lot of data movement or a lot of data network traffic is there. After that, it is not required. Everybody catching it, guys? Quick yes, please. Okay, then name node. Back to the name node, the same thing. All the servers or the workers or the developers are sending heartbeat. Every 3 seconds, they send a signal, a ping signal, and say, I'm alive, I'm all right. And he's making note, yes, he's alive, these servers are alive. If one of them doesn't send it, it updates it. Every 10th heartbeat is a block report, means every 10th, which is every 30th second, they will send a complete list of all the blocks they have. How much free space is there? How much is the available space versus, how much is not available? That is called the metadata. Okay, so there is stat, okay. See stat, and we have stat with the directory, setrep, okay, fs count. Okay, I guess what we can do is these are things we can save for tomorrow and continue from here tomorrow. Everybody with me, guys? Quick yes, please.
Sir.
Okay. So by the end of the day, in about an hour, I'll send the latest slides and things like that, guys. You can keep them and you can try to review them. And we'll dig a little bit deep into it in the coming updates. Cool. For today, I'll stop it here. Any questions before I wrap up, guys? Oh yeah, the commands. Yeah, one more. I'll upload the file, but let's say, so control save. I'm going to copy these things just for a quick this thing. I'll see if I can paste them in the chat window. Select everyone. Paste it. Sys.csv. I think it has a limit on how much I can send it. But let me see. Dropbox, Google. How come I don't have an option to send it from my directory? From local computer, it is not allowing me. That's very strange. Okay. Here are a few of them. I'll upload this file to our Google Drive, guys. Okay. Upload this one. File upload. Okay. Done, guys. I should be able to access the commands from the TM directory. If any of you have any problems, let me know. And we'll continue the journey from tomorrow, guys. Okay. Signing off for today. You guys take care, stay safe. If time permits, please try to practice them once or twice. And we'll continue the journey from tomorrow. Okay, guys. Signing off for today. Thank you. Bye for now.
Sir.
Thank you, guys.
Sir.